Welcome to the text recognition section of this course. Text recognition is a process of recognizing text in images or video. It can automate the data entry for credit cards, receipts, and business cards. And in this section, we are gonna use the text recognition feature of ML Kit library inside our Flutter applications. And by using this feature, we will get the bundle of different features. And the first one is recognizing text across Latin-based languages. So by using this library, we can recognize the text which is written in any Latin-based script. And the second advantage is analyzing structure of text. So as by using this library, we can detect the text in the form of lines, paragraphs, and words. So we get to know about the structure of recognized text as well. And the third advantage is identifying the language of text. So by using this library, we can also detect the language in which our recognized text is. So we can use this feature as per our use cases. And the fourth and the most important advantage is real-time recognition. So by using this library, we can recognize the text in real time. So we can build our real-time text recognition application using this library. And when we talk about text recognition, one important thing is text structure. So our MLKit text recognition library segments the text into blocks, lines, elements, and symbols. So a block is actually a continuous set of text lines such as a paragraph. And a line is a continuous set of words on the same axis. And an element is a continuous set of alphanumeric character just like a word. So there you can see in this picture when we are gonna pass it to our text recognition model, this first paragraph will be detected as a block. And then these sections with the blue rectangle around them will be detected as lines. And similarly, these things will be detected as individual words. And inside each of the block, we can still get the text in the form of lines or words. And same is the case with this line that we can still get the recognized text in the form of words inside this each line. So that is the structure of our text recognition library, that it returns the text in the form of blocks, lines, and elements. So what we are going to build in this section? Firstly, we are gonna build a Flutter application in which user will choose an image from gallery or capture it using camera. And then that image will be passed to our text recognition model of MLKit. And then we are gonna show the recognized text returned by the model to the user on screen. And secondly, we are gonna build a real-time text recognition application in Flutter. So we are going to display the live camera footage inside our Flutter application, and then we are gonna pass this live camera footage to our text recognition model frame by frame. After that, based upon the results returned by the model, we will draw the rectangles around detected text on screen along with the text itself. So as this section involves exploring text recognition feature of MLKit library in detail and building two very exciting applications, so let's begin. Hello and welcome to this lecture. In this lecture, we will start building our text recognition application in Flutter, and we are gonna perform that text recognition with images. So user will be able to choose images from gallery, or he can capture the images of documents using camera inside that application. After that, we are gonna pass those document images to our text recognition model, and our model will gonna detect the text present in those images. So now let's start. So the first step is getting the starter application code from GitHub. So open your browser and type this URL, or you can also take this URL from project resources. And once the repository is open, just click on the code button and copy this repository link. Now open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now our project is cloned successfully, and here let's firstly run this application inside our emulator and see what does this starter application contain. And then we are gonna add the text recognition feature inside this application. So I am going to install this application inside our emulator. So now our application is installed inside the simulator, and that's the GUI of this application. So here you can see we got this notebook image, and below that we got this paper and pen. So when the user will gonna click on it, the gallery will be opened and he can choose an image from gallery. So let's choose a document image here. So for example, I'm gonna choose this image. And here you can see the image that we chosen is being displayed here. Similarly, when the user will gonna long click on it, the camera will be opened and he can capture an image. Like he can capture the image of his credit card or some other document. And then that image will be displayed here, as you can see that. So now once the user will gonna choose or capture these images, we are gonna pass those images to our text recognition model, and then the text present in these images will be shown here on this notebook image. So that is our starter application code that user can choose images from gallery or capture images using camera. And now after looking at this starter application, let's look at this application code. So firstly open your pubspec.yaml file, and here you can see in the dependencies, we are using this image picker library to choose or capture the images. And when you will go inside your main.dot file, here you can see we got the code which is displaying this screen. So when you will scroll down and go inside this build method, you can see the UI related code. So firstly we got this material app, and inside that we got this scaffold. And in this scaffold, firstly we are showing this background image. So here you can see using this box decoration we are showing this image. And all of these images are present inside our images folder. So here you can see this background image, this clipboard image, and this notebook image. So we added them inside our assets folder. So move back to our main.dot file, and here after displaying the background image, we are showing this notebook image as a background to this container. And inside this container, we are displaying this text widget. So now we added a text widget on this container, and as a background, we added a notebook image. So when our model will gonna detect the text and we are gonna show it inside this text widget, this text will be displayed on this notebook. So hopefully you are getting the point that how the detected text will be shown here on this notebook. Similarly, when you will scroll down, you will get the code to choose or capture the images. So here you can see we got a container, and in this container we added a stack. And in this stack, firstly we are showing this clipboard image, and above that we are displaying this elevated button. And in this elevated button we have set this on press and on long press listener. So when the user will gonna click on it, or he will gonna click here, then this image from gallery method will be called, and when he will gonna long click on it, then this image from camera method will be called. And we created these methods above, and in those methods we are using the image picker library to choose or capture the images. Similarly, when you will scroll down, here you can see in this elevated button, we are checking if this underscore image variable is not null. So in that case, we are gonna display the image that user have selected or captured. Otherwise, we are displaying this icon which was initially being shown here. So that's the GUI of this application, and now let's scroll up and see the code related to choosing or capturing the images. So you can see we are initializing our image picker here, and then inside this image from camera we are choosing the image by using this image picker.pick image method, and we are specifying the image source to camera. And here we are gonna get that image, and we are gonna convert it into a file variable and assign it to this underscore image. And after that, if this underscore image is not null, we are calling this do text recognition method. And inside this method, we are gonna pass this image to our text recognition model and get the detected text. but for now we did not have anything inside this method. And same is the case for this image from gallery, but we just specified the source to gallery instead of camera. So now when the user will gonna choose or capture the images, then we are calling this do text recognition method, and inside this method we are gonna pass those images to our text recognition model and get the detected text. And we are gonna do that inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously we have imported our starter application code and you have seen the working of that application. So in that application, user will be able to choose images from gallery or capture images using camera inside Flutter. And now we need to pass those images to our text recognition model and get the recognized text. So let's begin. So the first step is adding our text recognition library inside that Flutter application. So open your browser and go to this site pub.dev, and here search for Google ML Kit text recognition. So Google ML Kit text recognition. Now press enter, and in the search result just click on this first link, this Google ML Kit text recognition library, and here the documentation page is opened. So firstly let's click on this installing section so that we can copy the dependency to add it inside our pubspec.yaml file. So just copy this line and open your Android Studio, and here go to this pubspec.yaml file, and below this image picker add the dependency. Now click on this pub-get so that this library will be downloaded and added inside our Flutter application. So there you can see this library is successfully added. After that, move back to the documentation page, and here click on this readme button so that we can read the instructions. And here you can see the first instruction is reading about the requirement and known issues of this plugin. So just click here, and now we can read the requirements for Android and iOS. So for Android, the things are quite simple. We just need to verify that our minimum SDK version is 21 and our target and compile SDK versions are 31. And you can verify them by going inside this Android, expanding this app and going inside this build.gradle file. And here you will scroll down and you can see that our minimum SDK version is already 21. Similarly, you need to verify your target SDK version and the compile SDK versions. And I have already set them to 31. And if you are not sure, then you can manually specify 31 here. So that is the requirement for Android. Now go to the documentation page and read the requirements for iOS. So for iOS, our minimum iOS deployment target should be 10 and we should be using Xcode 13 or newer. Similarly, we should be using Swift 5, and after that we need to change this setting inside our Xcode. So inside Xcode, go to runner, building settings, excluded architecture, and here you need to choose this ARMv7. And once you will choose that, your pod file should look like this. So these are the requirements for iOS and you can verify them. Similarly, let's click on the back button so that we can read the next instructions. And the next instruction is creating an instance of input image. As inside our application, we are able to choose images from gallery or capture images using camera. And now we want to pass those images to our text recognition model. But we cannot pass them directly. Firstly, we need to convert those images into this input image format. And the process is quite simple. So open the application code and go to our main .dart file. And here you can see once the user will gonna choose or capture the image, we are calling this do text recognition method. So inside this method, we are gonna convert this image into our input image format. So now we got our image in the form of file stored inside this underscore image variable. So here, in order to convert it into our input image, we are gonna create an object of type input image, and we are gonna name it input image. And here, before initializing, let's click on this input image and add the import. So click on this input image and press Alt plus Enter, and you can see the import for this library. And after that, let's initialize this input image. So we are gonna use this input image dot from file function. As we got our image in the form of file, so we are gonna use this from file function. And if you got your image path, then you can use this from file path function. Similarly, if you got your image in a bytes format, then you can use this from bytes function. So here we are gonna use this from file function, and now we are gonna specify this underscore image here and add a not null insertion, and that's it. So now we are converting the image that user have selected or captured into this input image format. So now let's look at the next instruction, and that is creating our text recognizer. So here, in order to create our text recognizer, we need to copy this code. So just copy this line and move back to the application, and we are gonna initialize our text recognizer inside our init state method. So here you can see we have pasted this code, and basically we are initializing our text recognizer. And here you can choose the language or the script you want to detect. So by default it will be Latin if you want to detect for English. Similarly, you can choose Chinese, Japanese, Korean and other formats, but we will stick with Latin. And now, in order to use this text recognizer outside of this init state, we need to declare it above. So here let's copy this text recognizer and remove this final. After that, we will create a dynamic variable and we will name it text recognizer. So now we have declared our text recognizer here and initialized it inside our init state method. So when this line will be executed, our text recognition model will be loaded. And now we can simply pass our input image to this text recognizer and get the detected text. And in order to do it, open the documentation page. And here you can see the next instructions are related to processing that image. So we are simply passing our input image to our text recognizer and getting an object of type recognize text. And after that, we are iterating it and getting the information in various forms. So firstly copy this code and then we are gonna explore it. So here inside our do text recognition method, we are gonna paste this code. So I'm gonna paste it here. And there you can see we are passing our input image to this text recognizer dot process image method, and we are getting this recognize text object. And inside this recognize text object there are number of things. Firstly, in order to just get the text present in a string format, we can use this recognize text dot text property, and it will gonna return us all the text which is present inside that image. After that, you can also access that text in the form of blocks, lines and words. And for each block or for each paragraph, you can get the location of that paragraph by using this block dot bounding box property. So there are some mistakes in the documentation, but we can correct them by ourselves. Similarly, you can get the corner points using this block dot corner points, and it will gonna return a list of points instead of offset. So here when you will click on it and press Alt plus Enter, you can see change list offset to list of points, and the error will be gone. Similarly, you can get the text present in each block and also the languages which are recognized by our model. So if that block is containing 2 or 3 languages, then you can get the names of those languages here as well. Similarly, for each block, you can get the lines. So here, firstly, inside this recognize text, we are getting the blocks or list of blocks by using this blocks property. And then we are iterating this list of blocks. And now for each block, we can get the lines using this blocks.lines. And we can iterate it using this for loop. And for each line, we can get the bounding box, the corner point, the text, and the language is present. And after that, we can divide it further and get the text in the form of elements, or elements are just like word. And for each word, we can get its location, the text, the corner point, and the language. So there is plenty of information returned by our model. But now firstly, we are gonna display the text that our model has detected inside this notebook. And in order to do that, we need to store this recognized text.text inside our result variable. Because inside our GUI, you can see we are displaying the text which is present inside this result variable. So we declared this variable above, and now we can store the recognized text inside it, and that text will be visible here. So scroll down, and here we are gonna assign this text to our result variable. So result, and then we are gonna assign this text, and that's it. So this recognized text.text will actually gonna return all the text in single string, but we can also access it using paragraphs, lines, and words, and we are gonna do that later. But for now, you can see we are storing it inside our result variable, and now we can move this line inside our set state block so that wherever this result variable is being used, the changes will apply. So let's cut this line and paste it inside this set state block, and that's it. So now when you are gonna run this application and choose or capture the document image, that image will be passed to this text recognizer, and we are gonna show the recognized text inside this notebook. So let's run this application again and test it. So now the application is installed again, and here let's test it by choosing the image from gallery. So here I'm gonna choose this document image first. And here you can see we got the detected text printed on this notebook image. Similarly, we can also scroll it because we have put this text widget inside our single child scroll view. So here you can see the single child scroll view. Similarly, as this text is quite small, so we can increase its size by changing the value here. So let's double it and press Ctrl plus S. And there you can see the text size is increased. So firstly we got this header 1, header 2, and after that we got this text. So you can check the accuracy of this model by comparing these two texts, and it is quite accurate. Similarly, let's choose this credit card image and see whether it will gonna detect the things or not. So here you can see we are getting the name of the bank, then the credit card number, then the card holder, and after that we are getting some more information. But it is actually detecting the name and this number quite accurately. So we can use this feature inside our applications for credit card scanning as well. Similarly, let's choose the other credit card image. And here you can see again we are getting the type of card, the number, and also the date along with the name of the holder. So this text recognition model is working quite well. As now we have tested our application and it is working quite well, now let's look at this output further. So as you can see, we are simply displaying the text inside this notebook, but we can get the text in the form of blocks, lines, and elements. So here we are using this for loop to iterate the blocks, and for each block we can get the lines using this for loop, and for each line we can get the elements using this for loop. And now we can again show this information inside this notebook or inside this result variable using these loops. So for now, let's comment these lines. And after that, we are gonna show the same information but using these for loops. So now for each word present inside this card or present in a document, this loop will be executed and we can show the text word by word. So now here we are gonna concatenate our result variable. So result plus, and after that we are gonna show the text contained inside that element. So element.text will gonna return us the text present, and the bounding box will gonna return a rectangle object indicating the location of that text in the image. So here we will firstly get the text, and after that for each word we are gonna add a space, and that's it. Similarly, now for each line we need to add a new line character. So outside of this for loop, or when this loop will be executed for each line, then we are gonna add a new line character to our result variable. So hopefully you are getting that point, because it should be clear for you that how you can access the information using these blocks, lines or elements. So now for each line, we are adding a new line character so that the text of the next line will be displayed on a new line. Similarly, for each block, we can concatenate this result variable, and we can add the same one new line character or two new lines character as you want. So for now, we will stick with the one. So now when these loops will be executed, again the text recognized will be stored inside this result variable. But this time we are using these loops. And now we can simply again call the set state block and pass the result variable here. And before this for loop, we need to reset this result variable so that each time when the user will gonna choose a new image, this variable will be reset and no previous detected text will be shown. And that's it. So let's run the application again and see whether we are getting the same result or not. And here let's choose the image. So firstly we are gonna choose this credit card image. And here you can see we are again getting the same text, but this time with a little bit more spacing. And that is because of these new line characters we added for blocks. But the information is same that we got previously. Similarly, we can choose a document image and check the results. And there you can see for this document we got this text shown here. And you can test this application by installing it inside your real device, and then you will get the idea that how accurate the results are. Welcome to this lecture. So previously we have completed our text recognition application, and in this lecture we will quickly cover the steps we took to complete that application. So firstly we got our starter application code from GitHub, and in this application we were using the image picker library to choose images from gallery or capture them using camera. After that we added this Google ML Kit dependency to perform text recognition. And now inside our main method, we got the code to choose or capture the images. So we got this image from camera or this image from gallery method. And when the user will gonna click on this clipboard, the image from gallery method will be called, and here he will gonna choose an image from gallery. And when he will gonna long press on it, this image from camera method will be called, and he will gonna capture an image using camera. And once he will gonna choose or capture the image, we are gonna call this do text recognition method, and inside this method we are performing the text recognition. So for that purpose, firstly we declared and initialized our text recognizer. After that we are using it here and passing our input image to this text recognizer, and we are getting this recognized text object. Then we can simply display the detected text using this text property, or we can display the detected text in the form of blocks, lines and elements. So we are storing the text detected inside this result variable, and after that we are calling this set state block. So wherever this result variable is being used, the changes will apply, and we are using it inside our GUI inside this text widget. So now the detected text is visible on this notebook image because we added this widget above this notebook. So that's how our text recognition application is working. Welcome to this lecture. In this lecture, we will start building our real-time text recognition application in Flutter. As previously, we have explored this text recognition API and we have implemented it with images inside Flutter. But now we are gonna use it with the live camera footage to detect or recognize the text in real time. So let's begin. So the first step is getting our starter application code. So open your browser and type this URL, or you can also take this URL from project resources. And once the repository page is open, just click on the code button and copy this link. Then open your Android Studio and here click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the project is cloned successfully. So let's firstly run this application inside an emulator and see what does this starter application contain. And after that we are gonna add our text recognition feature. So I am going to install this application inside an emulator. So now the application is installed inside the simulator, and here it is firstly asking for the camera permission and the permission to access the microphone. So let's give both of these permissions. And now here you will see that our live camera footage will be displayed. So that is the default preview for the emulator camera. And when you are gonna run this application inside your real device, you will see that your live camera footage will be displayed here. So that is our starter application, that we are displaying the live camera footage. And now let's look at this application code. So open your pubspec.yaml file and here scroll down. And there you can see in the dependencies we got this camera dependency, and with the help of this dependency we are showing this live camera footage. And similarly we got this Google ML Kit text recognition dependency as well. And we have learned inside our previous section where we integrated this text recognition with images that we are using this library to perform text recognition. And we will come to this part later inside this section. So here we have this camera dependency, and inside our main.dot file we have the code to display this live camera footage. And here you can see firstly we are getting the list of cameras inside our main method. So here all the cameras available will be stored inside this list of cameras. After that, let's look at the GUI. So inside our build method we got the GUI related code. So scroll down and you can see this build method here. So inside this method you can see we got this scaffold and then this app bar, and this app bar is displaying this text recognizer. After that, in the body we got this stack, and then here in the children's we got this stack children variable. So whatever view we want to display inside this stack, we are gonna add them inside this stack children list. And we defined this list above. So here you can see this list of widget named stack children. And firstly, inside this stack children, we are adding this position widget. So with the help of this position widget, we can specify the location of a widget. Like here we are specifying the top left point and the width and the height of its children. So in the child property, we are passing this container which is containing our camera preview. So with the help of this camera preview, we are displaying this live camera footage, and we added it inside this stack children, and then this stack children is being displayed inside this stack. So our live camera footage is being displayed here inside our GUI. And in the constructor of this camera preview, we are passing this camera controller, and we initialized it above inside our initialize camera method, and we are calling this method inside our init state. So here when this activity will be created, this initialize camera method will be called, and here we are initializing our camera controller and choosing the camera for which we want to display the footage. After that we are choosing the camera quality, and then we are calling this controller.initialize method. So if the camera is successfully loaded, then we are gonna call this start image stream method, and here we can get the frames of our live camera footage one by one. And we have covered all of this camera related code inside our second section of this course, where we learn to display the live camera footage in Flutter. So now when the camera will be loaded, we will start getting each frame of the live camera footage one by one inside this block. And now here the next step is passing this frame to our text recognition model and getting the detected text. And for that purpose, we are calling this do text recognition method here. And inside this method, we are gonna add the code to perform text recognition. But for now we got this code, and with the help of this code we are ensuring that only one frame will be passed to our text recognition model at once. So we are checking if this isBusy variable is false. So in that case this block will be executed, and we are gonna set this variable to true, so that now the next frame will not be passed to our model until we are gonna set this isBusy variable to false. And after that we are assigning that frame to this img variable, and then calling this do text recognition on frame method. And inside this method we are gonna pass this frame to our text recognition model, and we are gonna display the results. And then we are setting this isBusy variable to false, so that now the next frame will be passed to our model and we can get the results for it. But for now, we did not added our text recognition related code, and we are gonna add it inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously, we have imported our starter application code for text recognition, and in that application we are displaying the live camera footage, and now we need to perform text recognition, and after that we are gonna show the results printed on screen. And to do that, we are gonna use this Google ML Kit text recognition library. So firstly we need to install it. So in this installing section you can see the dependency that we need to add, and there you can see this dependency, and we have already added it inside our pubspec.yaml file. So inside our pubspec.yaml file you can see this dependency. After that, open the documentation page and click on this readme button, and here we have the instructions, and here the first instruction is verifying the requirements for Android and iOS. So you can read about these requirements here on this link, and we have covered this link inside our previous section. So you need to set these settings for iOS, and you need to verify that your minimum SDK version is 21 and your target and compile SDK versions are 31 for Android. And if you did not complete the previous sections, then you must do it, because there we have covered these things in detail. So now move back to the documentation page, and here the next instruction is creating an object of type input image. As we want to pass the frames of our live camera footage to our text recognition model, so firstly we need to convert those frames into this input image format. And to do that, open the application and go to our main .dot file. And here you can see this do text recognition on frame method will be called once a frame is available for passing it to our model. So here we firstly need to convert that frame into our input image format. And to do that, we got this method get input image, and inside this method we are converting the current frame into our input image format. As you can see, we are assigning the current frame to this img variable, and that variable is of type camera image, and we declared it here. So now our current frame will be assigned to this img variable, and inside this get input image method we are converting that frame into our input image format. So there you can see it is creating this input image and returning it. So now inside our method we are gonna uncomment that line, and we are gonna convert our current frame into our input image format. And then the next step is passing this frame to our text recognition model. And to do that, we firstly need to initialize our text recognizer. So open the documentation page, and here you can see the next thing is creating an instance of text recognizer. So open the project, and here inside our init state we are calling this initialize camera method, and inside this method we are initializing our text detector. So here uncomment this line, similarly uncomment the declaration of this text recognizer. So we are declaring it here and then initializing it inside our initialize camera method, and we are choosing the script to Latin, but you can also choose the other languages like Chinese, Japanese, Korean and so on. So here when this line will be executed, our text recognizer will be loaded, and the next step is passing our image to this recognizer and getting the result, and that thing we are doing it here. So here you can see we are passing our frame image to this process image method, and it will gonna return us an object of type recognize text. So when this image will be passed to our text recognizer, we are gonna get this object, and the next step is getting the text using this recognize text object. And one way is to simply get all the text at once by using this recognize text.text property, and you can print that text in the console and verify it whether your application is working or not. So till this point we are displaying the live camera footage inside this application, and then for the frames of our live camera footage this do text recognition method is being called, and inside this method we are converting that frame and then passing it to our model, and after that we are getting this recognized text, and then we can simply print it inside our console and see whether our application is working or not. And after that, we are gonna draw the rectangles around detected text on screen and also gonna show the text along with the rectangle. So as this text recognition model is also detecting the location of the recognized text along with the text, so we can also draw the rectangles on screen where the text is being displayed. So that is our ultimate goal. But for now, you can simply run this application inside your real device, and then in the console you can check whether you are getting the recognized text or not. So you should got the recognized text when you are gonna put your camera on some paper or on some surface where some text is written. So this model will gonna recognize it and it will gonna show it inside the console. So now we are getting the recognized text for each frame of the live camera footage here, and you should have verified it by installing it inside your real device. And after that, the next thing is drawing the rectangles around detected text and showing the text on screen along with the rectangle. And to do that, we are gonna make some changes inside this application code. So if you have completed the previous sections where we have performed the real-time face detection and object detection, then you already know the process. And if not, then follow me on this lecture. So in order to draw the rectangles around detected objects, what we are gonna do is to add a view at a same position where this live camera footage is being displayed. So where in the screen our live camera footage is being displayed, we are gonna add a transparent view above it, and then on that view we are gonna draw the rectangles, and it will gonna give us an impression that those rectangles are being drawn on our live camera footage. But in actual they are being drawn on a separate view, which is a transparent view, and on that view we are drawing those rectangles. And now let's do it. So scroll down. Firstly we need to add a view which is transparent, and on that view we are gonna draw the rectangles. So inside our build method you can see this commented code. So just select it and uncomment it. So now this code is adding this build result method, or the widget returned by this build result method, at the same position where we have added our live camera footage. So now this widget will be displayed exactly above this live camera footage, because by using this position widget we have specified the exact same position. And the widget that will be shown is returned by this build result method. So scroll up and look at this method. So this method is returning a custom paint widget, and with the help of this custom paint widget we can draw anything on screen, like we can draw rectangles, circles, points, images, and so on. So now we need to draw the rectangles around detected text, so we are gonna use this custom paint widget to do it. And inside this custom paint widget we need to pass an object of a class which is implementing custom paint. So we have this text recognition painter class inside our code, and this class is implementing a custom painter. So here you can see this class, and we will come to this class later, but you can see at the bottom we got this class. So we are specifying this class here. So basically we are creating an object of type this class and then passing it here. And in the parameters we are passing two things. Firstly we are passing the size of our live camera footage which we are getting using this controller. And the second thing is we are passing our recognized text object. So here you can see we are passing this scan result variable, but at the top you can see inside our do text recognition method we got the scan result variable, and we are assigning our recognized text to it. So just uncomment it, and there you can see that. So we are assigning this object to our scan result variable, and we are doing it inside our set state block. So now when the live camera footage will be displayed and we will start getting the frames of that live camera footage, then we are calling this do text recognition method for those frames. And inside this method we are gonna pass those frames to our model, and we are gonna get the results. And then we are storing those results inside the scan result variable. And because of this set state, wherever the scan result is being used, the changes will apply. And we are using it here inside our build result method. So here you can see we are checking if the scan result variable is null or the camera controller is not initialized. So in that case we are not going to display this custom paint widget. And if the scan result variable is not null, so in that case we are gonna pass the scan result here and we are returning our custom paint widget. So now this custom paint widget will be displayed exactly above this live camera footage. And inside this text recognition painter class, we are drawing the rectangles for the detected text. So now scroll down and look at this class. So inside this class, we are getting the size and the recognized text. After that, for this class, the paint method will be called whenever it will be visible inside our GUI. And inside this paint method, we got the canvas. So now whatever thing we are gonna draw on this canvas will be visible on screen. And we are gonna draw the rectangles around detected text by calling this canvas.drawRect method. But before that, let's look at these variables. So firstly, we are creating or calculating two values, the scale x and scale y. So we are calculating the scale x by dividing the size of this custom paint with the size of our live camera footage. Similarly, we are calculating the scale y variable by dividing the height of this custom paint widget with the height of our live camera footage. And we are gonna use these variables to scale the points returned by the model, as we need to draw the rectangles exactly around the text which is detected. So in order to do that, we need to scale the points returned by the model based upon our screen size and our camera preview size, so that those rectangles will be drawn exactly above the text. And we are gonna use these variables for that purpose. And after that, you can see we are iterating this recognize text dot blocks array. So this recognize text dot block will gonna return a list of text block, and for each block this for loop will be executed. And you can consider this block equivalent to a paragraph inside text. So now for each paragraph this for loop will be executed, and we can get the rectangle for that block by using this block.boundingbox property. Similarly, we can get the corner points, the text of this block, and the language is present inside it. And after getting all of this information, we can use it as per our use case. But we are gonna use this bounding box and we are gonna draw the rectangle. And here in order to do it, we are gonna use this canvas.drawRect function. And inside it, we are gonna create our rectangle object using this rect dot from left top right bottom function. So here we need to specify these 4 points: the left point of the rectangle, the top point, the right point, and the bottom point. So in order to get the left point, we are using this block.boundingbox.left. And after that, we are scaling it by multiplying it with this scale x variable, so that this point will be shown at a correct position on our screen. Similarly, we are getting the top point, the right point, and the bottom point. So for the left and right point, we are multiplying it with scale x property, and for the top and bottom, we are multiplying it with the scale y variable. And after that, the second parameter of this drawRect function is a paint object. And by using this paint object, we can customize the rectangle that will be drawn. Like we can choose the color of the rectangle. So here you can see we are creating this paint object, and here we are choosing the color to brown. Similarly, you can choose the style that the rectangle will just gonna contain a stroke or a border, and it will not be filled with this brown color. And similarly, you can choose this stroke width or the border width here. And by changing these properties, you can change the look of the rectangle. So now here, for each block of the text, this loop will be executed, and we are drawing the rectangle around detected text on screen. Similarly, after drawing the rectangle, the next thing is showing the detected text on screen as well along with the rectangle. And to do that, we need to show this block.text, and below that we got the code for that purpose. Firstly, we are creating a text span for this block.text property, and here you can choose the size of the text and the color. After that, we are creating our text painter and passing this span here, and here you can choose the text alignment and the direction. After that, we need to call this text painter.layout function, and then finally we can draw this text on screen by using this text painter.paint function. So firstly, inside this method we need to provide the canvas on which this text will be drawn. After that, we need to specify the location that where this text will be shown. So for each block we are drawing a rectangle, and now we are gonna show this text at the top left position of that rectangle. So this text will gonna start showing from the top left corner of the rectangle, and it will gonna give us an impression that it is being drawn inside that rectangle. So here we are specifying this offset object or a point object. So we need to specify the top and left point here. So firstly we are getting the left point of that block and scaling it by multiplying it with this scale x. And after that we are getting the top point and scaling it by multiplying it with scale y. So now when this method will be executed, this text will be printed on screen along with the rectangle. So now let's run this application inside our real device and see whether we are getting the rectangle drawn around detected text or not. Similarly, we are gonna see that the detected text will also be shown inside that rectangle. So let's test our application. So now we have installed the application inside our real device, and there you can see when I am pointing the camera at this document picture, our application is detecting the text in real time. So we are getting the rectangle drawn around the detected text, and then in this rectangle we got the recognized text as well. So there you can see a lot of text is being detected here. Similarly, when I'm gonna point it at my keyboard, you can see it is also detecting the alphabets written there. But for this document, you can see the result is 100% accurate. And you can run this application inside your real device and test it by yourself to check the accuracy of this model. So now we have tested our application and it is working correctly. As now we are drawing the rectangle for the blocks and we are showing the text of those blocks inside that rectangle. But we can do it for each line or for each element as well. Because for each line we are getting the bounding box, the corner points, the text and the recognized language as well. And similarly for each element we are also getting its location, text, recognized language and corner points. So if you want to draw the rectangle around each line, then you need to move this code inside this inner for loop. So we need to move this code where we are drawing the rectangle around each block to inside our inner for loop along with this code to draw the text. So just cut the text from here and move it inside this for loop for each line. So I'm gonna paste it here. And now here instead of block we are gonna use this line. So just copy it and paste it here. Similarly replace it here, here and here. And now for this text we need to change it here as well. And after that when we are specifying the location of the text we need to specify line here as well. So change it here. And that's it. Now when you are gonna run this application, you will see the rectangle will be drawn around each line of the detected text and you will get that text printed inside that rectangle. Similarly, you can change the font size and the color by changing these properties here. And if you want to do it for each word, then you can move this code inside this inner for loop and do it for each element of the detected text. So here for text recognition, we are getting this recognized text variable and inside it we got the blocks. And for each block we got a list of line. And for each line we got a list of elements. So it is up to you that which information you want to use for your own use case. So hopefully you got the idea. So now let's quickly review the process that how we have built this application. So firstly, we got our starter application code from GitHub, and in that application we are using this camera package and this Google ML Kit text recognition package. So this camera package is for displaying the live camera footage, and this text recognition package to perform text recognition. After that, inside our main.dot file, we are displaying the live camera footage by adding this camera preview inside our stack children. So this stack children will be displayed in the body of our scaffold. And at the same position where we have added this camera preview widget, we are also adding this build result method, which will gonna return a custom paint widget. So exactly where we are displaying this live camera footage, we are also displaying this custom paint widget, but this custom paint widget will be a transparent widget. And on this custom paint widget, whatever thing we are gonna draw, it will gonna give us an impression that it is being drawn on our live camera footage. And we are gonna use this custom paint widget to draw the rectangles around detected text. But before that, we performed our text recognition above. So here, when we are initializing this camera controller and displaying the live camera footage, here we are getting each frame of the live camera footage one by one. And then for those frames, we are calling this do text recognition on frame method. And inside this method, we are converting that frame into our input image format and passing it to our text recognizer. And we are getting this recognized text object. And then we are assigning it to this scan result variable inside this set state block. And we are passing this scan result or this recognized text to our text painter class. So here you can see inside our custom paint we are specifying this painter, and it is a class of type text recognition painter. So we are passing the recognized text object to it, and this class will gonna draw the rectangles around detected text, and it will gonna show the recognized text as well on this custom paint widget. So scroll down and you can see this class, and inside this class you can see we got the canvas, and on this canvas we are drawing the rectangle around detected text for each line. Similarly, we are showing the text contained by that line also inside the rectangle that we are drawing. So now when this code will be executed, our live camera footage will be displayed inside Android, and when we are gonna scale a surface which contains some text, the rectangle will be drawn around that detected text, and we will also get the recognized text drawn on screen. Welcome to pose estimation section of this course. Pose estimation is a computer vision task that detects the pose of a person or object in an image or video. This is typically done by identifying, locating, and tracking a number of key points on a given object or person. For objects, this could be the corners or other significant features. And for humans, these key points represent major joints like an elbow or knee. We can clearly see the power of pose estimation by considering its application in automatically tracking human movement. From virtual sport coaches to AI-powered personal trainers, pose estimation has the potential to create new tools to measure human movement precisely. In addition to tracking human movement and activity, pose estimation has application in a range of areas, such as augmented reality, animations, gaming, and robotics. And in this section, we are gonna use this feature and build couple of different Flutter applications. Firstly, we are gonna build a Flutter application in which user will choose an image from gallery or capture it using camera. Then that image will be passed to our pose estimation model, and based upon the results returned by the model, we are gonna draw the lines joining different body joints. And secondly, we are gonna build a real-time pose estimation application in Flutter. So we are gonna display the live camera footage and pass it to our pose estimation model frame by frame. After that, based upon the results returned by the model, we are gonna draw the lines by joining different body joints in real time. So we are gonna build a real-time pose estimation application. As the section involves building two very exciting applications, so let's begin. Welcome to this lecture. In this lecture, we will start building our pose estimation application in Flutter. And in this application, we are gonna use pose estimation with images. And later we are gonna use our real-time pose estimation application in Flutter. So the application we are gonna build, in that application, user will be able to choose images from gallery or capture images using camera. And then that image will be passed to our pose estimation model, and we will draw the points at the location of different body joints, and we are gonna join them using line. So in short, we are gonna detect the pose of that person. So let's begin. So the first step is getting our starter application code. So open this URL, and once the repository is opened, copy this link. Then open your Android Studio and click on this Get From Version Control. Now paste the link here and click Clone, and our application will be cloned in a moment. So now our application is installed successfully. So let's firstly install this starter application inside an emulator and see what does this starter application contain. After that, we are gonna look at this starter application code, and then we are gonna perform pose estimation. So I'm gonna install this application inside an emulator. So now our starter application is installed, and that's the GUI of this application. So here you can see we got this background image, and above that we have this box, and in the center we got the camera icon. So when the user will gonna click on it, the gallery will be opened and he can choose an image from gallery. So let's choose this image. Similarly, when he will gonna long click on it, the camera will be opened and he can capture an image using camera. So let's capture this image, and you can see this image is being displayed here. And after choosing or capturing the image, we need to pass that image to our pose estimation model, and then based upon the results returned by the model, we are gonna draw the sketch that what pose this person is taking. But before that, let's look at the starter application code, and then we are gonna perform that pose estimation. So open this pubspec.yaml file, and here you can see in the dependencies we got this image picker library, and by using this library we are choosing or capturing the images. So inside our application you can see we got this code. And firstly, let's look at the GUI. So inside our build method, we got this material f and this scaffold. And then we are displaying this background image using the decoration property of this container. And we got this image inside our images folder. So you can see this image here. After that, we are displaying the box which was displaying the camera icon and this image view. So here when you will scroll down, you will see this elevated button. And we have set this on press and this on long press listener on this elevated button. So when the user will gonna click on it, this image from gallery method will be called. And when he will gonna long click on it, this image from camera method will be called. And inside these methods, we have the code to choose or capture the images. So here you can see we are using this image picker to capture the image using camera. So here we are calling the pick image method and specifying the source to camera. So when this line will be executed, the camera will be opened, and once the user will gonna capture the image, we are gonna get that image and convert it into our file format. And after that we are calling this do pose estimation method. Similarly, for gallery, we are specifying the source to gallery, and here once the user will gonna choose the image, we are gonna convert that image into this file format and again call this do pose detection method. And inside this method, we are gonna add the code to perform pose estimation using the image that user have captured or selected from gallery. Similarly, when you will scroll down, you can see after adding these listeners, we have this container. So in this container, we are checking if this underscore image variable is not null, which means that user have selected or captured an image. So in that case, we are displaying that image. Otherwise, we are displaying that container with the camera icon in the center. So that is our application layout, that we are choosing or capturing the images using our image picker library. And we have covered this code in detail when we learned to choose images from gallery or capture images using camera in Flutter with the help of this library. So you can check that section for further details. But for now, we got this application where user can choose or capture the images, and inside our next lecture we are gonna perform pose estimation using the images that user will gonna choose or capture. So see you in the next lecture. Welcome to this lecture. As previously we have imported our starter application, and in that application we are choosing or capturing the images, and now we need to perform pose estimation using the image that user will gonna choose or capture. And for that purpose we are gonna use a package name Google ML Kit pose estimation. So open your browser and go to this link pub.dev, and here we need to type Google ML Kit pose estimation. So after typing it, press enter, and this library will be shown in the search results. So there you can see this library, so just click on it and the documentation page will be opened, and here we can read the instructions to use this library. But firstly we need to install it, so click on this installing section, and there you can see the dependency. So just copy this dependency and paste it inside our pubspec.yaml file. So I'm gonna paste it here below this image picker, and now click on this pubget so that this library will be downloaded. So there you can see this library is downloaded in 9.5 seconds. After that, move back to the documentation page, and here click on this readme button to read the next instructions. And there you can see the first instruction is, before you get started, read about the requirement and known issues of this plugin here. So just click here and the requirement page will be opened. And on this page you can read the requirements for iOS and Android. So for Android the things are quite simple. We need to check that our minimum SDK version is 21 and our target and compile SDK versions are 31. And we can check them by going inside our Android section and by opening this app folder, and here you can see this build.gradle file. So when you will scroll down, here you can see this minimum SDK version, this target SDK version, and this compile SDK version. So I have already set this minimum SDK version to 21 and this target and compile SDK versions to 31. And if you are unable to verify it, then you can manually specify them here. So 21 here, 31 for this target SDK version, and 31 for our compile SDK version. So specify 31 here, and that's it. Now open the documentation page and read the requirements for iOS. So for iOS, our minimum iOS deployment target should be 10, and we should be using Xcode 13 or newer. Similarly, we should be using Swift 5, and then we need to change this setting inside Xcode. So go inside project, runner, build settings, excluded architecture, and here you need to choose this ARMv7. And after choosing it, your pod file should look like this. So these are the requirements for iOS, and you can verify them if you are doing that development on iOS. And after that, let's open the documentation page so that we can read the next instructions. And here when you will scroll down, you can see the next instruction is creating an instance of input image. As we are building a pose estimation application where user will gonna choose or capture the image, and we want to pass that image to our pose estimation model. But we cannot pass that image directly. Firstly, we need to convert that image into our input image format. And to do that, open our main.dot file, and here scroll to the method do pose detection. So you can see this method here, and this method will be called once user will gonna choose or capture the image, and now we need to perform pose estimation using that image. So firstly, let's convert that image into our input image format. So let's declare an object of type input image, and after that we are gonna name it input image. And then we are gonna use this input image dot from file function. So here you can see we got three functions. Firstly, this from file, which we are gonna use to convert our image file into this input image. And if you got your image file path, then you can use this from file path function. And if you got your image in a bytes format, then you can use this from bytes function. So here we are gonna use this from file, and we are gonna specify our underscore image here. After that, add a not null insertion, and that's it. So now our image will be converted into this input image format. And the next step is creating our pose detector object. So open the documentation page and you can see we need to create an object of type pose detector. And to do that, we are gonna use these lines. So just copy them and we are gonna paste them inside our init state method, so that whenever this screen will be visible, our pose detector will be loaded. So firstly we are creating this pose detector options, and then we are passing it to our pose detector. So when these lines will be executed, our pose detector will be loaded. But we cannot access this pose detector outside of this init state, so let's declare it above. So just copy this pose detector and we are gonna declare it above. So dynamic and name is pose detector. Similarly, remove final from here, and that's it. So now we are creating our pose detector and specifying the options. And by using these options, you can customize certain things. Like here, we got the option to specify the mode and the model. Like when you will type mode here, there you can see you can choose the pose estimation mode. So pose estimation mode, and here we got two options. Firstly, the stream. So you can use this stream mode when you are performing pose estimation with the live camera footage. As we are using the images, so we are gonna use this single mode because it is more accurate. Similarly, the second thing is model. So there are two choices for the model. First one is a base model and the second one is a more accurate model. So when you are gonna write this model here, then you can choose the pose estimation model. So pose estimation model, and add a dot and you can read the options. So firstly we got this accurate model, then got this base model. So let's choose base for now, and then we are gonna try the accurate model later. So now our pose detector is loaded, and the next step is passing our image to that model and getting the result. And to do that, open the documentation page, and the next section is processing image. So here in this section we are gonna process our input image and we are gonna get the list of poses. So just copy this code and then we are gonna look at it. So I'm gonna paste this code inside our do pose detection method. So here below this line paste the code, and there you can see we are passing our input image to this process image method and we are getting this list of pose in the result. So now when our image will be passed to this model, we will get this list of pose. After that we can iterate this list and show the result to the user. And here you can see there are a couple of errors. Firstly, there are no closing brackets for this for each loop. So just add them and add a semicolon and the error will be gone. Similarly, let's right click and click on this reformat code with dark format so that our code will be formatted. And now let's look at it. So for each pose this loop will be executed, and inside each pose we got a number of landmarks. So this model will gonna detect the location of different body joints like ankles, knees, shoulders and so on. And we are gonna use those points to detect the pose of a person. So here this pose.landmark will gonna return a hash map where the key will be the landmark type and the value will be the pose landmark object. So here we are iterating this map using this for each loop, and for each key value pair this loop will be executed. And we can get the type of landmark using this landmark.type property. Similarly, we can get the x and y position of that landmark using this x and y properties. And we can show this information to the user on screen in the console, and we can also use this information to draw the points on this image. So firstly, we are gonna show this information in the console, and we are gonna see where our model is detecting something or not. So here inside this for each loop, we are gonna print the data. So here firstly we are gonna print that type. So it is of type force landmark type. So type, and then we are gonna use the name to get the name of that landmark. After that we are gonna add some spaces, and then we are gonna show the x point. So using this x variable we are gonna get it, and then add couple of more spaces and show the y variable. And we need to call this toString method for both these x and y. So here let's add toString. And one more way to print that information is using the interpolation. So here you can see this suggestion, use interpolation to compose string and values. So I'm gonna click on this replace with interpolation, and you can see now using this $sign we can print these values. So let's run this application inside our emulator again and see whether we are getting the names of the landmarks and their points in the console or not. And then we are gonna draw this information on this image. So let's run this application again inside the simulator completely. So now our application is installed inside the simulator. So let's test it by choosing an image from gallery. So here we are gonna choose this Usain Bolt image. And you can see this image is being displayed here. And now let's check the console that we are getting the information or not. So there you can see we are getting a lot of information here. So we are getting the information for nose, and we are getting the location. After that, for the left eye inner, left eye outer, right eye inner, right eye outer. Similarly for the ears, mouth, shoulder, elbow, wrist, pinky, index, thumb, hip, knee, ankle, heel, foot index, and so on. So we are getting the location of all of these body parts by using this model. And now we can use this information and draw a sketch indicating the pose of this person. So this application is working till this point, and the next step is drawing the lines along with the points on this image indicating the pose. And we are gonna do that inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously we have performed pose estimation and we are getting the results printed in the console. And now we want to draw the detected points on this image along with the lines which will gonna join these points. And to do that we are gonna follow some steps, as we want to draw those points and lines on this image. So for that purpose we need one such view where we can firstly draw this image, and then on this image we can draw those points and lines. And that view or that widget is a custom paint widget. So inside our application GUI you can see we are displaying our image here, and if the user did not select any image we are showing this container. So overall this code is present inside this container. So now it's time to remove this container. So just select all of this container and remove it. After that you can see this commented container. So just select all of it and uncomment it. And now inside this container we are using our custom paint widget. So there you can see certain errors and we will resolve them in a moment. But you can see now we added this container, and in this container we are checking this image variable. So if this image variable is not null, so in that case we are gonna display our custom paint widget, and if it is null, so in that case we are gonna display the box with the camera icon in the center. So now let's look at this custom paint. So this is the widget using which we are gonna firstly draw this image, and then above this image we are gonna draw those points and lines. So we added this custom paint widget here, and inside this widget you need to pass a class which is implementing a custom painter class. and that class is this pose painter. So we created this class below, so you can see this class at the bottom of your file. So just select all of this code and uncomment it. So this is actually a class which is extending this custom painter, and in this class we are passing our list of poses and our image file, and this class will gonna draw that image on the canvas, and then it will gonna draw those points on that canvas. And we will cover this code in a moment, but for now scroll up and here you can see this error is gone. So now we need to resolve this image variable error and this poses variable error. So this image is actually the image that user will gonna choose or capture from gallery, but we need to convert that image into a format called UI.image, because our custom paint will gonna take our image in that format. So inside our code, let's uncomment both of these lines. So here firstly we are creating or declaring our image variable and then our list of poses. And now inside our doPoseDetection method we need to remove this declaration so that the poses will be assigned to this poses array. So now when the user will gonna choose or capture the image, then this method will be called, and here we are gonna pass this image to our model, and we are gonna get the results and store them inside our list of poses. After that we need to convert this underscore image to our UI.image format, and to do that we got the code inside this drawPose method. So just select it and uncomment it, and inside this method we are getting the image which is in a file format and reading it as a bytes. After that we are decoding this image by using this decode image from list method and passing the image again, and this time we are gonna get that image in a format called UI.image. So that is our required format, and we are gonna call this drawPose method inside this doPoseDetection method. So at the bottom let's call it so drawPose, and that's it. So now when the user will gonna choose or capture the image, and that image will be passed to our model and we will get the results. After that we are calling this drawPose method, and here we are gonna convert that image into this UI.image format, and then we are calling this setState block. So wherever this image is being used, the changes will apply, and we are using this image variable inside our UI to show this custom paint widget. So now inside this custom painter we are passing our list of poses and this image in a UI.image format. And the next portion of work is done inside this pose painter class, where we are gonna draw this image, and then above this image we are gonna draw the points and line. So let's look at this pose painter class. So inside this class we are getting our list of pose and this image file, and when this pose painter will be shown inside our custom paint widget, this paint method will be called, and here we can get the canvas. So whatever thing we are gonna draw on this canvas will be visible inside our UI, and we are drawing our image using this canvas.drawImage method. So we are passing our image file and then specifying the location. So it will be drawn starting from the position where this custom paint widget will gonna start. And after drawing the image, the next step is drawing the points or circle at the location of body joints. And to do that you can scroll down, and here you can see we are iterating our list of poses, and for each pose we are getting the landmarks, and for each landmark map we are iterating it using this for each loop. And here inside this loop we are drawing a circle at the position of each landmark. So we are using this canvas.drawCircle method, and inside it you need to specify the location where this circle will be drawn, and that location is specified using this offset object. So we are specifying this offset or the location using this landmark.x and landmarks.y properties. So now this circle will be drawn at that point, and then we are specifying the radius. After that you can specify the paint object, And by using this paint object, you can choose the color of the circle along with the style. So we are choosing the color to green, and then we are choosing the style to stroke. So it will be a circle just with a border, and the border width will be 4. And now when this code will be executed, for each landmark for this pose, we are gonna draw a circle at the location of that landmark, and that circle will be of color green and its width will be 4. And now we can simply run this application and verify these changes. So I'm gonna install the application again, and here we are gonna test whether we got the points at the location of body joints or not. So let's select an image, and here when we are gonna choose this image, you can see now we got these green dots drawn at the location of each body joint. So we got it on foot, ankle, knee, hip, shoulder, eyes, cheeks, and so on. So there you can see we got these green points drawn on our image. So our application is working correctly. And the next thing is drawing the lines joining these body joints. Like we want to draw a line which will gonna join this ankle with this knee, then this knee with this hip with this shoulder, and this shoulder with this hand, and so on. So in order to do that, we got the code commented inside our application. So here you can select all of this code and uncomment it. So I'm gonna select it till this point and uncomment it. And this code is quite easy to read. So firstly, we are creating this function named paintLine. So this function will gonna take 3 things as a parameter. Firstly, it will gonna take 2 pose landmark type objects, this type 1 and type 2. Like if we want to draw a line joining this ankle with this knee, so we need to pass this ankle as a first object and this knee as a second object. And this method will gonna draw a line joining these 2 points. And the third parameter is a paint type. So by using this paint object, you can choose the line. So after getting these parameters, we are getting the pose landmark object for these types. So using this pose.landmarks map, we are gonna specify the key which will be the type of pose landmark, and we are gonna get the value which will be a pose landmark object. And by using this pose landmark object, we can get the location of that pose landmark. So here after getting them, we are gonna draw a line using this canvas.drawLine function. And here we are gonna specify 2 offset objects, and the line will be drawn joining these 2 offsets. So the first offset will gonna contain this joint1.x and joint1.y value, and the second offset will gonna contain joint2.x and this joint2.y value. So now this line will be drawn joining these 2 points, and here we are passing this paint type as well. So we have this method, so whatever 2 pose landmark types we are gonna pass, it will gonna get the location for them and draw a line. And now we need to call this method carefully. So here firstly we got the code to draw the arms, and to draw the arms we are gonna call this method, so paintLine, and here we are gonna specify the type. So we are gonna draw a line joining the left shoulder and left elbow, and we are specifying this left paint object here. So we created 2 more paint objects above. So for left side of joints, we are gonna use the color yellow, and for right type of joints, we are gonna use the blue accent color. So now here for the left one, we are passing this left paint object. So the line will be drawn joining the left shoulder and the left elbow. So here you will see a line joining them. Similarly, in order to join the left elbow and the left wrist, we are gonna call this method again. And after that, we are gonna call it for right shoulder and right elbow to right wrist. So now the lines will be drawn joining the shoulders with elbow and joining the elbows with wrist. And after that, to draw the body, we are gonna draw the line from the left shoulder to the left hip. So a line will be drawn from here to here. Similarly for the right one, right shoulder, right hip. So the line will be drawn from here to here. And after that we have the code to draw the legs. So we are gonna draw a line from left hip to left knee. So the line will be drawn from this left hip to left knee. After that, a line will be drawn from this left knee to left ankle. So a line will be drawn from here to here. And then for the right one. So right hip to right knee, and from right knee to right ankle, and that's it. So now when this code will be executed, we will get the lines drawn joining these joints. So let's run this application and see whether we are getting these lines or not. So here the application is installed again, so let's choose the same image. And here you can see we got the blue line for the left side and the yellow line for the right side, and it is indicating the pose of this person. Similarly, let's test it for a different image, like we are gonna use this image. And here you can see we got the points drawn for this image as well. And finally, let's use this other image. And there you can see we got these lines drawn for these points as well. So our application is working correctly, and now apart from the points, we are also drawing the lines joining these body parts. So now let's look at the steps we took to complete this application. So firstly, we imported this starter application code from GitHub, and in this application we are using the image picker library to choose or capture the images, and this Google ML Kit pose detection library to perform pose detection. After that, inside our main.dot file, we got the code for this GUI. So when you will scroll down inside your build.gradle file, you will see that we have this elevated button, and in this elevated button we are displaying this container. So when the user will gonna click on it, the gallery will be opened, and when he will gonna long click on it, the camera will be opened and he can capture an image using camera. So we got this code here inside these methods, and once the user will gonna choose or capture the image, this do pose detection method will be called, and here we are gonna pass that image to our pose detector, and we are getting our list of poses. After that, we are calling this draw pose method, and inside it we are converting our image into this UI.image format, and then calling this set state method. And wherever this underscore image is being used, the changes will apply, and we are using it inside our GUI to draw the points and lines inside this custom paint widget. So here this block will be executed again, and we are gonna pass the results returned by the model and our image to this pose painter, and this class will gonna draw those points and lines. So here in this class we are gonna get the results and image. So on the canvas, firstly we are drawing the image, and then we are iterating our list of poses, and for each pose we are getting the map for landmarks. So for each landmark we are drawing a circle. So there you can see these green circles. After that, we are drawing the points joining the left shoulder with the left elbow with the left wrist, and so on. So the lines will be drawn using this method paint line, and you can see these lines joining the body joints. So that's how our application is working, and we are performing pose estimation and drawing these circles and lines. Welcome to text translation and language identification section of this course. As the name suggests, text translation provides the facility to translate between any two languages. And by using language identification model, we can identify the language of a text. And in this section, we are gonna use the text translation and language identification feature of ML Kit library. And the library provides us a number of features. And the first one is broad language support. So by using this library, we can translate between more than 50 different languages. So you can create a text translation application to translate between any of the two languages. And the second advantage is proven translation models. So in this library, we will get the same translation models used by Google Translate. So these are the most accurate translation models which we can use inside our applications. And the third advantage is dynamic model management. So by using this library, we can download the translation model for any language and also delete them. So there will be no storage related issue because we can download the model when we need and also delete them when we don't need them. And the fourth advantage is on-device machine learning. So as our translation model will be downloaded inside our mobile device, so the translations will be performed quickly because there is no internet connection required to perform the translation. Our model will be present inside the device itself and we can use it anywhere at any time. And in this section, we are gonna build a Flutter application to translate text between two languages. So user will gonna enter the text in a specific language and then by using our translation model, we are gonna translate this text into another language. And we will also learn to download the translation models inside our application by using this library. Similarly, we are gonna build a Flutter application to use our language identification model. So we are gonna build a Flutter application where user will gonna enter a text in a specific language and then by using our library, we are gonna detect that in which language the text is written. As the section involves building two very exciting applications, so let's begin. Welcome to this lecture. In this lecture, we will start building our text translation application in Flutter. So the application we are gonna build in which we are gonna translate the text between two languages. And that translation can be between any of the two languages which our ML Kit library supports. So let's begin. So the first step is getting our starter application code from GitHub. So open your browser and type this URL, or you can also take this URL from project resources. And once the repository is opened, just click on the code button and copy this link. Then open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application is cloned successfully. So let's firstly run this starter application inside an emulator and see what does this starter application contain. And after that we are gonna add the text translation feature inside this application. So I am going to install this application inside an emulator. So now the application is installed inside this emulator and that's the GUI of this starter application. So here at the top we got this banner. So on one side we got the text English and on the other side we got this text Urdu. So we are gonna build an English to Urdu translator. So Urdu is my national language and I'm gonna create a translator which will gonna translate the text from English to Urdu. And below that you can see this edit text. So here the user will gonna enter the text in English and when he will gonna click on this translate button, we are gonna pass this text to our translator and our translator should return that text or it should translate that text into Urdu language. And we are gonna show this translated text inside this text widget that we got below. So that's the GUI of our application. That user will gonna enter the text here and when we are gonna click on this translate button, we are gonna translate that text using our ML Kit library and we are gonna show the resultant text here. So after looking at the flow of this application, let's quickly look at this application code. So firstly open our pubspec.yaml file and in the dependencies you can see we did not added any library yet. So after that open our lib folder and go to this main dot dot. And here let's firstly look at the GUI. So scroll down and inside our build method we got the GUI. So here you can see we got this scaffold and then inside it we have this container. And in this container we got the column widget. And now in this column widget we actually got our layout widgets. So firstly you can see in this column widgets we got 4 container widgets. So in the first container we are displaying this section, this English and Urdu section with the red color in the background. So expand this container, and here you can see in this container we have a card and we are setting the color red. So that's why we got the red color here. After that we got a row, and in this row firstly we are displaying this text widget with the text English as you can see it here. Similarly we are showing a white color bar, and then we are displaying the text Urdu here. And if you are building some other translator like English to German translator, then you can change the text here like German. So that was the first container. After that we got this section where user can enter the text. So for that purpose expand this second container, and inside it you can see we got this text field. So in this text field user will gonna enter the text that he want to translate. So here we are setting this text editing controller so that we can get that text and pass it to our model. Similarly, we are showing the hint text and the fill color here. So that is our second container, which is showing this text field where user will gonna enter the text. After that, let's look at the third portion or third container, and inside it we are displaying this button with the text translate. So you can see this elevated button and the background color is green, and we are showing the text translate here. Similarly, if you want to change any color or you want to change any text here, you can simply do that. And finally, for the fourth container or for this portion where the translated text will be shown, you can see we have a card widget, and inside it we have a container. And in this container we have this text widget, and in this text widget our translated text will be shown. And here we are displaying the text which will be stored inside this result variable. So we declared this result variable above, and inside it we are storing the text translated text. And whatever value we are gonna store inside this result variable, it will be shown inside this container. And we are gonna store the translated text once our model will gonna return it. So we are displaying our translated text here in this container. So that is the GUI of our application, and the next step is when the user will gonna enter the text here and he will gonna click on this button, then we need to pass that text to our model and show the translated text here. And to do that we will complete the code inside our next lecture. So see you in the next lecture. Welcome to this lecture. As previously we got our starter application code and we have looked at that starter application, and now it's time to add text translation inside that application. So to do that we are gonna use this Google ML Kit translation library, and you can simply open the documentation page for this library by visiting this site pub.dev, and there you can search for this Google ML Kit translation. And here you can open the documentation page, and now we can follow the instructions to use this library and perform text translation. So the first instruction is installing it. So click on the installing button and here copy this dependency. After that open your Android Studio and go to our pubspec.yaml file and scroll below. Inside our dependency section we are gonna paste this line. Now click pubget so that this library will be downloaded. And there you can see in 2.3 seconds this library is downloaded. After that open the documentation page again and go to this readme section. And there we got the instructions to use this library. Firstly we should read the requirements, so just click here and the requirement page will be opened. And here we got the requirements for both Android and iOS. And for Android the things are quite simple. Firstly we need to check that our minimum SDK version is 21 and our target and compile SDK versions are 31. And you can check them by going inside your project and expanding this Android section. And here inside app open this build.gradle file. Now here when you are gonna scroll down, you will see this minimum SDK version here. So this minimum SDK version, this target SDK version, and this compile SDK version. So there you can see it. So this compile SDK version should be 31 and our minimum SDK version should be 21. So change it to 21 and the target SDK version should be 31. And that's it. So these are the settings for Android. After that, open the documentation page and read the requirements for iOS. Our minimum iOS deployment target should be 10 and we should be using Xcode 13 or newer. And our Swift version should be 5. After that, we need to change the setting inside our Xcode. So inside Xcode, go to Project, Runner, Build Settings, Excluded Architecture, and here you should choose this ARMv7. And after choosing it, your pod file should look like this. So these are the requirements for iOS. So after verifying the requirements for Android and iOS, move back to the documentation page and here read the next instructions. And the next instructions are creating our text translator. So there you can see this own device translation, and it means that our translation model will be present inside the application where we are performing the translation. So usually the translation is done in such a manner that when the user will gonna enter the text, we pass that text to our model using some APIs, which means that our translation model is hosted somewhere. It is not present on the device. But in our case, we are gonna perform own device translation, which means that our model will be present in the device where we are performing the translation. So firstly, that model will be downloaded and then we can use that model without any internet connection. So that is what own device translator means, that we don't need any internet connection once we are gonna download the model. Then we can use it anywhere without any internet connection. So here, in order to perform the translation, what we need to do is to create our own device translator object. So in order to do it, we got the code here. So there you can see we are calling this own device translator and we are specifying two things. Our source language, which will be the language in which we are gonna enter the text, and the target language, which will be the language to which we want to translate the text. Like if we want to translate the text from English to German, then our source language will be English and our target language should be German. But in order to perform this own device translation, our source language and our target language models should be downloaded in the device. And we can easily download them with the help of this library. So firstly, we need to download the model for our English language and for the German language, and then we can perform the translation. And as in our case, we are translating the text from English to Urdu, so we need to download the model for English language and the Urdu language, and then we can create this translator and perform the translation. So in order to download those models, you will see the code below. So here you can see we got this code to create our own device translator model manager. And then with the help of this model manager, we can check if a model is present on the device or not. Similarly, we can download the model using this model manager and also delete the model if we want to. So firstly, let's create this own device model manager. So just copy it and paste this code inside our main.dot file. So here open this main.dot file and above inside our init state method, we are gonna paste this code. So just paste the code here. And now just click on this error and press Alt plus Enter and add the import for this Google ML Kit translation library and the error will be gone. So now we are initializing our model manager here, but we need to declare it above so that we can use it outside of this init state method. So I'm gonna declare it here. So dynamic, and I'm gonna paste it here, and that's it. Now remove this final. And now we are declaring our model manager here and initializing it inside our init state method. And the next thing is checking whether the models are present in the device or not. And if the models are not downloaded, then we should download it. So to do that, open the documentation page and here you can see the next section is check if the model is downloaded or not. And to do that, you can see this code here. So just copy it and then we are gonna take a look. So open the application code and here you can see inside our init state, after initializing our model manager, we are calling this method check and download model. So inside this method, we are firstly going to check whether the models are downloaded or not. So here below this first to do, just paste the code. And in this code, you can see we are using this model manager. So we are using this model manager dot is model download function. And then we are specifying the language for which we are checking that whether that model is downloaded or not. So if you want to check that the model for English is downloaded or not, then you can pass this translate language.english.bcp code here. And if you want to check it for a different language, then you can pass that language here, like Arabic, Urdu, Afrikaans, Bengali, and so on. So as firstly we want to check it for English, so we are gonna keep it that way. After checking for the English, we also want to check whether the model for Urdu is downloaded or not. So to do that, let's copy this code again and paste it below. And now here change the language to Urdu. And now we need to rename these variables. So let's firstly rename this variable to is English downloaded. Similarly, let's rename the second variable to is Urdu downloaded. And that's it. So now when these lines will be executed, if the model for English language is downloaded, then it will gonna return true here. And if not, then it will gonna return false here. Similarly for the Urdu, we are gonna check whether the model is present or not. And after checking if the models are not downloaded, then we need to download them. And to do that, open the documentation page and you can see this line to download the model. So just copy this line and we are gonna paste it below. So here to do download models if not downloaded. So just paste the code here. And now we are calling this model manager dot download model function. And here we are specifying the language for which we want to download the model. So if the model for English is not downloaded, only in that case we are gonna call this function. So let's add a if statement. So if this is English downloaded is false, only in that case we are gonna call this line. So here if it is false, so in that case we are gonna download the model for English language. Similarly we are gonna check for the Urdu. So let's copy these lines and we are gonna paste it below, that if this is Urdu downloaded is false, only in that case we are gonna download the model for Urdu. So change it to Urdu as well. And that's it. So now when this method will be executed, we are gonna wait until the models are downloaded. And if the models are successfully downloaded, then this response will gonna contain true, otherwise it will gonna contain false. So now in order to keep track that whether our model is downloaded or not, let's declare these variables above and we are gonna use them here. So let's firstly remove this final from boolean variable, also remove it from here. And now let's copy this boolean is English downloaded and paste it above. And we are gonna set it to false for now. Similarly, let's do the same for our is Urdu downloaded. So just copy it and paste it above and set it to false. And now we are gonna remove this boolean from here. So remove this bool and also this bool. So now we created these variables above and by default they will be false. And if the models are already downloaded, then they will be true, and in that case these lines or these sections will not be executed. And if these variables are false and our model is not downloaded, so in that case our model will be downloaded using this download model function. So when this function will be called, if the model is successfully downloaded by using this function, then we are gonna set the values of those variables again. So we are gonna set this is English downloaded and also this is Urdu downloaded here, so that if not previously these models are downloaded and they are downloaded now, so we can check and create our translator. So now if the models for English and Urdu are downloaded, we can create our translator, and we are gonna do that below. So here inside our to do, if models are loaded, then create translator. And to do that, open the documentation page and here you can see the code to create our translator. So just copy this line and here we are gonna paste them below. And now here you can see we are creating our own device translator. And now we need to specify two things, our source language and our target language. And we can specify them using our translator language property. So translator language, and as our source language is English, so we are gonna choose it. Similarly, our target language is Urdu, so we are gonna choose Urdu here. Translate language dot Urdu, and that's it. So now when this code will be executed, our translator or our own device translator will be loaded. But we are only going to create this translator if our models are downloaded. So just add an if condition and check if the English model is downloaded. Also, the Urdu model is downloaded, so only in that case we are going to create our translator. So here add a closing brace, and that's it. And we need to declare our own device translator above so that we can use it outside of this method. So let's declare it here. So dynamic, and we are declaring it here and initializing it inside this method. So now let's look at this method again. So inside our init state, this method will be called. And in this method, firstly we are checking if for our source and target language, the models are downloaded or not. So if the models are not downloaded, then we are gonna download them. And once the models are downloaded, then we are creating our own device translator. And the next thing is using this translator and performing translation. And the next thing is using this translator and performing translation. And to do that, we have this method translate text. So when do we need to perform the translation? And the answer is when the user will gonna click on this translate button after entering the text here. So here when you will scroll down, inside the third container you can see inside this on press listener for our button, we are calling this translate text method, and here we are passing the text that user have entered inside this block. So now when the user will gonna click on this button, we need to perform translation. And to do that, we are gonna add the text inside this translate text method. So here we are gonna use this on device translator to perform translation. But the translation will be performed only if the English and Urdu models are downloaded. So again we are gonna add that check. So here paste the line. And now we are checking if the model for English and Urdu are downloaded. So in that case we are gonna use this on device translator. And to do that, open the documentation page, and here you can see in order to process the text or translate the text, we need to call this on device translator dot translate text function. So just copy this line and paste it inside this block. And here you can see we are calling this translate text function of our own device translator, and we are passing the text that user have entered inside this block. And this method will gonna return us the response in the form of string. So this string is actually our translated text. And now we can simply show this translated text inside this block or inside this text widget. And to do that, we need to store this text inside our result variable. So here add a set state block, and now we are gonna assign the text to this result variable inside it. So pass this response here, and that's it. So now when the user will gonna enter some text here and he will gonna click on this translate button, this method will be called, and here we are getting the text that user have entered. And now we are checking if the models are downloaded, then we are passing this text to our translator and getting the translated text. And we are assigning the translated text to our result variable, and we are using this result variable inside our GUI to show the text. So there you can see we are using it inside our text widget. So now the translated text will be visible here. So let's install this application inside our emulator again and test this application. So I'm gonna install the application again. So now the application is installed again, so let's test it by entering some text inside this text view. Like I'm gonna enter the text life is Beautiful. And now let's click on this translate button and see whether we are getting the translated text or not. So there you can see we are getting the text Zindagi Khoobsurat Hai here, and that is the meaning of this text inside my language. So this text translator is working quite well. Similarly, you can check it for your native language by specifying or changing the target language to whatever language is your native language, and then you can test this application effectively. And when you are gonna install this application first time inside your device, you will see in the top bar the model downloading will be visible. So you will see that the model is being downloaded and what is the progress of that downloading. So for now we have built this English to Urdu translator and it is working quite well. And if you want to change it for your own language, then you need to specify this target language to whatever language you want to use. And you can see the options here, this Chinese, Danish, Dutch, Finnish, French, German, Greek, and so on. So there you can see we got a number of options here, and you can create the translator for any of these language. So after specifying your target language here, you need to check that the model for that language is downloaded or not by changing the value here. And if the model is not downloaded, then you can download it by changing the name here. Like you want to download the model for French, then you can specify French here. And that's how you can customize this application for your native language. So now let's quickly review the process that how we have built this application. So firstly we got our starter application code from GitHub, and in this application we have this GUI. So here the user will gonna enter the text, and when he will gonna click on this translate button, we are passing that text to our translator and showing the resultant text or the translated text here. So in our starter application, we got the code for our GUI, but we are not performing the text translation. And to do that, inside our pubspec.yaml file, we added the dependency for this Google ML Kit translation library. After that, inside our main.dot file, inside this init state, firstly we are creating our model manager object. And by using this model manager, we are checking whether the model for our source and target language are downloaded or not. So if we want to perform the translation from English to German, then we need to check that the model for English language and the German language is downloaded or not. So using this model manager, we are checking if the models are downloaded or not. So if the model is not downloaded, then we are downloading it using this model manager. And similarly, once the models are loaded, we are creating our translator object. And here we are specifying our source language and our target language. And after that, once the user will gonna click on this translate button, then we are getting the text that he entered here, and we are calling this translate text method. And inside this method, we are passing that text to our translate text method of this own device translator. And we are getting the response, which is our translated text. And we are showing this text on screen inside this text widget. So that's how we are performing text translation in Flutter. So now we have completed this application, and in this application we are performing text translation. And the next thing is performing language identification. And that is actually the feature using which we can recognize that what is the language of text that user have entered. Like if he is entering the text in German language, then using that language identification library, we can identify the language in which user have entered the text. And now we are gonna add the code to do that. So here, if you did not complete the previous lectures where we have integrated this text translation library in Flutter, then you must do it, because we are continuing or using the same application that we built there. So that is our application code, and here we are performing text translation. And now we are going to perform language identification. So what we are gonna do? So we are gonna pass this text that user have entered here to our text translator, to our language identification model, and we are gonna get the language in which this text is written. And then we are gonna show the name or language code here along with this text. Similarly, we are gonna pass our translated text to that library, and we are gonna check that in which language this translated text is. And we are gonna show the language code here as well. So now let's do it. So to do that, we are gonna use a different library. So open your browser and here go to this pub.dev and here search for Google ML Kit language identification. In the search result, you can see this Google ML Kit language ID library. So just click on it. And here we got the instructions to use this library. So firstly we need to install it. So click on the installing and copy this line. After that, paste it inside your pubspec.yml file. So I'm gonna paste it here below it. And now add the spacing and click on this pub-get so that this library will be downloaded. And there you can see in 2.5 seconds this library is downloaded. And now let's open the documentation page again and click on this readme button and scroll down, and there you can see in order to use this feature we need to create our language identifier object. So let's copy this line and paste it inside our init state method. So here inside our main dot we are gonna paste it inside our init state. So let's paste it here. And there you can see we got an error, so just click on it and press Alt plus enter, and now add the import for this library. So there you can see we are creating our language identifier object, and inside it we are passing this confidence threshold value and we are setting it to 0.5. So it means that when we are gonna pass some text to this language identifier, then this language identifier should try to detect the language of that text, and then it will gonna assign a score to each detection. And if the score is less than 50%, then it should ignore that detection, otherwise it will gonna keep it. So we are creating our language identifier here, but we need to declare it above. So just copy it and create a dynamic variable here and paste it here. And let's remove this final from here. So now we are declaring this language identifier here and initializing it inside our init state method. And when this line will be executed, our language identifier model will be loaded. And now we can use it. So to use it, open the documentation page, and here you can see we can simply call this language identifier.identify language function, and we are gonna pass the text here, and this function will gonna return the language of that text. So here let's copy this line, and after that we are gonna use it inside our main dot, and here we are gonna use it inside our identify languages function. So just paste the code here, and now you can see we got this method identify languages, and here we are getting a string as input, and we are gonna call this function inside our translate text. So when the user will gonna enter some text here and he will gonna click on this translate button, in that case along with the text translation we are also going to identify the language. So here after that we are gonna call this identify text function as well. So identify languages, and we are gonna pass the text that user have passed as input. So let's add a semicolon and that's it. So now when this line will be executed, this function will be called, and we are passing the text that user have entered here inside this method. And inside this method we are passing that text to our language identifier, and it will gonna return the language code for the detected language. Like if the text is in English language, then we are gonna get the response which will be the code for English language, and that code is EN, which is for indicating English. And if the text is in Urdu, we are gonna get the code UR, which is the language code for Urdu language. So now after getting this language code, what we need to do is to show this code here along with this text. And to do that we are gonna use the editing text controller that we are using with this text field. So inside our layout you can see we got this text field and we are using this text editing controller. and by using this controller we can edit the text that user have entered here. So now we are gonna do that. So here we are gonna use this text editing controller, and then we are gonna set the text here, and the value we are gonna set is by concatenating this variable. So whatever text this controller is containing, we are gonna concatenate it, and we are gonna add the braces, and inside these braces we are gonna show the language code. And to do that we are gonna use the interpolation, so add a $sign, and here we can use this response, and now add a semicolon, and that's it. So now when this line will be executed, our response code will be added at the end of this text here, and you can confirm it by running the application again. And as now we have added another library, this language identifier, so we need to install the application again and test it. So click on this stop and then install the application again. So now the application is installed again. So again let's add some text. So I'm gonna use the same text, and let's click on this translate button. And here you can see we got the translated text, but apart from that we got this text en inside this braces. So basically we got the language code concatenated in this text field. So our language identification model is working correctly, and we are getting the identified language code here. Similarly, we can detect the language of our target text, and to do that we need to again call this function, but this time we are gonna specify the result variable text here, because we have stored the translated text inside this result variable. So just copy this line again, and we are gonna execute it. So here let's change it to response 2, and now change this variable to result, so that the result text will be passed to our model, and the language code will be stored inside this response to variable. And now we can simply show it inside this text widget along with this translated text. And to do that we need to concatenate our result variable. So let's firstly call this set state block, and inside it let's concatenate our result variable. So we are gonna concatenate this result variable, and here we are again going to use the interpolation. So firstly we are showing these braces, and then here we are calling this response to. Now add a semicolon, and that's it. So now when this method will be called, apart from the source language text, we are also passing the target language text to our language identifier, and it will gonna return the code for that language. And now we are concatenating it with our result variable. So let's run the application again and test it. So here add some input text, and I'm gonna click on this translate button, and there you can see apart from this en we are getting this UR, which is the language code for Urdu. So this model is detecting the language for both English and Urdu, as we firstly passed English language text to this model and it detected the language code to en, and then we passed Urdu language text to this model and it is detecting the code to UR. Similarly, you can test this feature by passing the text in different languages, and then you can check the language code. And when you will open the documentation page, here you can see apart from this identify language function, we got this identify possible languages function, and this function will gonna return the list of identified languages. So if we are passing a text where multiple languages are used, then we can use this function as well, and this function will gonna return all the languages which are present in that text. So you can simply iterate this list of identified languages, and then you can show the results and use it as per your use cases. But for now we have used this model and detected the text inside our application. And how we did that? Firstly, we declared our text identifier and initialized it inside our init state. After that, we are calling this identify language function and passing our input text, and it will gonna return the language code. Similarly, we can use the identify possible languages function and get all the languages present in that text. So it's up to you that whichever method you want to use or what method suits your use cases. Welcome to Smart Reply section of this course. With Smart Reply API, you can automatically generate relevant replies to messages. It helps your user to respond to messages quickly and make it easier to reply to messages on devices with limited input capabilities. You must have seen this feature in Gmail and in other applications with chat facility. And in this section, we are gonna use Smart Reply feature of ML Kit library inside our Flutter application. And the library provides us a number of features. And the first one is the Smart Reply model generates reply suggestions based upon the full context of the conversation, not just by using a single message. This means that our suggestions are more accurate and helpful to the user. And secondly, the on-device model generates replies quickly and does not require you to send user messages to a remote server. So there will be no security issue and the suggestions will be generated quickly as our model is present in the device itself. So what we are going to build in this section? We are gonna build a Flutter application in which user will send and receive the messages. And then we will pass the conversation to our Smart Reply model, and our model will gonna suggest the replies based upon the conversation each time user will gonna receive a message. So we are gonna build the complete simulation that how this feature will gonna work inside real user applications. So as the section involves exploring a very exciting feature and building a very unique Flutter application. So let's begin. Hello and welcome to this lecture. In this lecture, we will start using the Smart Reply feature of ML Kit library inside our Flutter application. And this feature can be used inside chat applications to suggest smart replies based upon the conversation that is being taking place. So you can use it inside your chat applications or inside the section of your app where you have some chat related functionality. So now let's start building our application in which we are gonna use this feature to predict or suggest the smart replies. So the first step is getting our starter application code. So open your browser and type this URL, or you can also take this URL from project resources. And here on this repository page, just click on the code button and copy this repository link. Then open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application is cloned successfully. So let's firstly run this application inside an emulator and see what does this starter application contain. After that, we are gonna use the smart reply feature inside this application. So I am going to install this application inside an emulator. So now the application is installed inside this emulator, and that is the GUI of this application. So in this application, you can see in the bottom we got this edit text and then this send button similar to WhatsApp. So here user will gonna write the text he want to send, like he want to send hi to someone, then click on the send button and this text is now disappeared. Similarly at the top we got another text view, and here user will gonna write the text that he will gonna receive, like when he is sending the text how are you, and in return he is receiving the text I am fine, then he will gonna type I am fine here and click on the send button. And then based upon the message that he sent and he received, we are gonna use our model and suggest the replies. So hopefully you are understanding the point that we are testing the smart reply feature of ML Kit library, and this feature will be used during conversations to suggest smart replies. So there should be someone who is sending some messages and receiving them, and then based upon the messages he is receiving, we are gonna suggest the replies. And in order to cover the case, for now in this application, we have created this situation. So here user will gonna write the text that he will gonna send, and here he will gonna type the text that he received. And then based upon the messages he sent and received, we are gonna show the smart replies or suggestions. And then we can evaluate those suggestions that whether they are relevant to the conversation or not. So that is the flow of our application, that user will gonna type the messages that he is sending here in the bottom and the messages that he is receiving in the top. And then based upon this conversation, we are gonna show the suggestions using our model. So now after looking at our application flow, let's quickly look at this application code. So firstly, inside our main.dot file, you can see this application code. So inside our build method, we got the GUI related code. So here you can see this build method. So inside this build method, we got the scaffold, and then inside it we are showing this container. And in this container, we are displaying the background image which is similar to the WhatsApp. And you can see in the images folder we got this bg.jpg. So we are displaying this background image, and after that we got a column widget, and in this column widget we got 3 containers, and these containers are displaying these 3 sections. So firstly, this first container is displaying this first text field along with this button. So let's expand it, and there you can see inside this container we got a row, and in this row firstly we are displaying this card which is containing this text field. So here in this text field, user will gonna write the messages that he is receiving. So here you can see this hint received text here. Similarly, we are setting this received edit text controller here to get the text that user have entered. And after displaying the card, the second thing we are displaying is this elevated button, which is this send button. So here you can see this button, and in this button we are displaying this send icon. Similarly, we have set an on press listener on this elevated button, and we are just clearing this edit text for now. But later we are gonna add the code to pass this reply from user to our model and get the smart suggestions. So that is the first container which is displaying this UI. Similarly, let's look at our second container where we are gonna show the results. So here in this container we got a text widget which is displaying the text present inside this result variable, and we have declared this result variable above. And in this variable we are displaying the text suggestions which is currently visible here. And later we are gonna store the smart suggestions returned by our model inside this result variable, and those suggestions will be visible here in this text widget. Similarly, we got the third container which is displaying this text field and this button. So here you can see this container that it is quite similar to this first container. So inside row we got a card widget, and inside this card widget we are displaying this text field, and here user will gonna write the text that he want to send. Similarly, we got our elevated button, and here we are displaying this send button, and when the user will gonna click on it, we are clearing this text field using the sender text editing controller. So we have also set the controller to this text field as well. So you can see this sender text editing controller, and we have declared and initialized both of these text editing controllers above. So here you can see this sender text editing controller and this received editing controller. So that is the GUI of our application, that we got the section to type the message that user want to send and also the message that he is receiving. And then based upon the conversation, we are gonna show the smart replies in the center. And of course the code for that thing will be added inside our next lecture. So see you in the next lecture. So now we are declaring this smart reply variable here and initializing it inside our init state. So we can use this smart reply object and get the smart suggestions. But before that, we need to pass the conversation to the user that is being currently happening. because based upon that conversation our model will gonna suggest some replies. So we need to pass the messages that he is sending and also he is receiving, so that our model can learn the situation and suggest the smart replies. And the same thing can be seen on the documentation page. So here you can see the next section is add messages to the conversation. So here you can see this smart reply dot add messages to conversation from local user. So this is the one method, and using this method you are gonna add or pass the messages that the user is sending, because local user is the user who is currently sending the messages. So in this method we need to specify the message that he is sending along with the timestamp or the time at which he is sending the message. Similarly, we got another method, and that is add message to conversation from remote user. And this is actually the message that he is receiving. And based upon both of these messages, our model will gonna suggest the smart replies. And mainly based upon the message that he is receiving from this remote user, this model will gonna suggest the reply. So here firstly copy this first line, and we need to paste this line or call this method once user will gonna type some message here and he will gonna click on this green send button, because we need to pass the message from our local user to that method, and that message will be the message that our user is sending, and he will gonna enter that inside this text field. So here scroll down and go to our third container, and now inside our elevated button, when he will gonna click on this button, we are gonna call this method. So just paste it here. So here you can see we are calling this smart reply dot add message to conversation from local user. And firstly we need to add the text or the message that he is sending, and we can get that text using this controller. So sender text controller dot text, and it will gonna return us the text that user have entered inside this text field. And the second thing is the timestamp, and the data type of this timestamp is integer, and we can get the current timestamp using our datetime class. So date time, and we are gonna call its method name now. And after that we can get that time in an integer format by using this milliseconds since epoch, and it will gonna return us current timestamp in milliseconds, and we are passing it here. And we are passing this timestamp so that our model can understand in which order these messages are being sent or received. And here, after passing the text that he is sending along with the timestamp, the next thing is passing the messages that he is receiving. So the next instruction is calling this add messages to conversation from remote user. So just copy this line, and we are gonna paste this line inside our first container, because that is the text field where user will gonna write the text that he is receiving. And once he will gonna type it and click on the send button, we need to pass this text to our model. So here scroll up and go to our first container, and now inside our elevated button above this received editing controller we are gonna paste it. So here you can see we are calling this smart reply dot add messages to conversation from remote user, and now we need to pass the text, and we can get it using this text controller. So using this received editing controller dot text property, we can get the text that user have entered here. After that we need to pass the timestamp, and we can get it using our datetime.now, and then we are gonna call milliseconds since epoch. And there is third parameter as well, and that is for user ID, and that ID will be a unique string. And in the chatting application we usually have a unique ID assigned to each of the person which is involved in a chat, so you can simply pass that ID here. But for now let's add quotation around it, and our ID will be user ID. and that's it. So now when the user will gonna enter the text that he received and click on this button, we are gonna pass the message to our smart reply model. But at the very same time, we should also show the suggestions based upon the message that he received. So the next code is getting the suggestions and showing it in the text widget. So open the documentation page and scroll down. And there you can see we are calling the smart reply.suggest reply method. And it will gonna return us a list of string, and that list will gonna contain the smart suggestions. So just copy this code and open our application. So here, after passing the text that he received, we need to show the smart reply suggestions that user can use. So after this receive edit text controller dot clear, which will gonna clear this text field, we are gonna paste this code. So just paste it here, and now you can see we are calling this smart reply.suggest replies method, and it is returning us a list of string, and that list is named as response. And after that we are iterating this list of string, and we are getting each suggestion one by one and showing it in the console. But we need to show these smart suggestions in this text field, and to do that we are gonna use our result variable. So there you can see we got our result variable here, and the text stored inside it will be visible inside this text widget in the center of screen. So now we are gonna assign this suggestion to our result variable. So here result, and then we are gonna concatenate it. So here we are gonna show the suggestion. After that we are gonna add a new line character, so that now the next suggestion will be shown on a new line. And you can replace this line of code with interpolation. So here you can see now we are using interpolation. So each of the suggestion will be concatenated to our result variable, and we are showing each suggestion on a new line. But before this for loop, let's quickly reset this result variable so that whatever text it is containing will be removed. So here let's reset its value to empty string. After that we need to call our set state block, and inside it we are gonna simply write this result. And we are doing that so that wherever this result variable is being used, the changes will apply, and we will see the new text visible in this text widget. So when you will scroll down, you can see we are using this result variable in this text widget. And now when the user will gonna type his message in this text field and click on this send button, we are passing that message to our smart reply model. After that, when he will gonna type the reply that he received here and click on the set button, we are passing that reply to our model as well. And after that we are using our smart reply model and getting the suggestions, and we are showing those suggestions inside this text widget because we are storing the suggestions inside this result variable. So now when you will run this application, you will see we got our reply suggestions printed in the center of screen. So let's run this application again and test it. So I'm gonna install the application again. So now the application is installed again, so let's test it. So for example, user is sending some message like how are you to someone. So let's click on the send button, and you can see this text field is empty, which means that now the message is passed to our smart reply model and we have cleared this text field. And now type the reply from that person. So as user is sending how are you, so the reply can be I am fine, how are you. So now let's click on this red button, and after that you can see in this suggestion box we got these three suggestions. So the first suggestion is I am fine, I am good, and the second suggestion is I am good, and the third suggestion is I am okay. And all of these three suggestions are quite relatable to the conversation. Similarly, after that user is asking where are you and clicking this button, and after that the reply from that person is I am at work. So now let's click on this red button again, and there you can see we got 3 new suggestions. So the first suggestion is okay, then I see, and the third suggestion is good. And all of these 3 suggestions are also quite good, because when someone is saying I am at work, then you can simply write the message like okay, good, or I see. So our application is working quite well. Similarly, you can use this model inside your real chat application, and you can give your user a facility of smart replies. So hopefully you got the idea that how this model is working. So based upon the messages that user is sending or receiving, the model will gonna suggest the replies, and the user can simply use these replies to answer quickly. So now we have completed this application, so let's quickly review the process that how we have built it. So firstly we got our starter application code from GitHub, and in this starter application code we have the GUI related code where we got these 3 sections. So here in the bottom section user will gonna write the text that he want to send, and in the top text field he will gonna write the replies or the messages that he received, and then based upon the messages that he is sending or receiving, our model will gonna suggest the replies, and we are gonna show these replies in this text widget in the center. So after getting our starter application code, we added this library Google ML Kit Smart Reply inside this Flutter project, and then we created an object of type smart reply and initialized it. After that we are adding the messages that user is sending or receiving inside this smart reply. So here you can see when the user will gonna click on this send button, this green one, we are adding the message to our smart reply by calling this add message to conversation from local user method. So we are specifying the message and the timestamp. After that, when the user will gonna type the messages that he is receiving and clicking on this red send button, we are again passing it to our smart reply model. But this time we are using this function add message to conversation from remote user. So our model can know that this is the message that user have received. After that we are using the smart reply.suggest reply function, and it is returning us the smart suggestions based upon this conversation, and then we are iterating this list of strings, and we are showing the suggestions to the user by storing them inside our result variable. So we are seeing these suggestions in the center of this screen because we stored them inside this result variable, and this result variable is being shown in this text widget. So that is our smart reply application. Hello and welcome to Entity Extraction section of this course. Entity extraction is the process of detecting and extracting useful information from text. For example, if we got this text, call the restaurant at this number to pay for dinner. My card number is this one, and we are gonna pass this text to our entity extraction model. Then that model can detect 2 entities are present in this text. Firstly, this phone number, and secondly, this credit card number. So with the help of our entity extraction model, we can extract the useful information from text and use it for different purposes. Apart from that, entity extraction improves the user experience inside your application by understanding text and allowing you to add helpful shortcuts based upon the context. Like inside the default chatting application, this feature is being used to detect different information like location, phone number, email, and so on. And in this section, we will learn to use entity extraction model of our ML Kit library. And by using this model, we can detect following entities like this address, date, time, email address, flight number, IBN, ISBN, money or currency, payments, credit cards, phone numbers, tracking numbers, and URL. So you can detect any of the information and use that model as per your use case. And the model supports a number of different languages, starting from this Arabic, English, Dutch, French, and so on. So you can use the model to detect entities in any of these languages. And in this application, we are gonna use this feature and build a very useful Flutter application. So we are gonna build a Flutter application to recognize different entities present in text. So user will gonna enter a text in a specific language. Then by using our entity extraction feature of ML Kit, we are gonna recognize different entities present in that text. So we will guide you to use this feature inside your Flutter applications completely, as the section involves exploring a very useful feature and building a very useful Flutter application. So let's begin. Hello and welcome to this lecture. In this lecture, we will start building our Flutter application where we are going to use the entity extraction feature of ML Kit. So we are gonna use this feature and we are going to extract the information in the form of entities from text. So let's begin. So the first step is getting our starter application code from GitHub. So open your browser and type this URL, or you can also take this URL from project resources. And once the repository page is opened, just click on the code button and copy this repository link. Then open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application is cloned successfully. So let's firstly run this starter application inside an emulator and see what does this starter application contain. After that, we are gonna use the entity extraction feature inside this application. So I am going to install this application inside an emulator. So now the application is installed inside this emulator. So that is the GUI of our application. So at the top you can see this text entity extraction, and below that you can see this box which contain a text field. So here in this text field, user will gonna type the text, or he can paste the text here in this text field. And then when he will gonna click on this extract entities button, then we are gonna pass this text to our entity extraction model, and our results will be shown in this box which is in the bottom. So here where we got the text extracted entities, we are gonna show the entities present in the text that user have typed or pasted it here. So that will be the flow of our application, that user will gonna paste the text here, and then we are gonna extract the entities when the user will gonna click on the button, and the extracted information will be shown in this text widget. So after looking at this application, let's look at this application code. So firstly open our lib and go to our main .dot file. So inside it, let's firstly look at our build method and understand the GUI of our application. So scroll down, and there you can see inside our build method, firstly we got our scaffold, and inside it we have this container, and there we have set this background image, and inside our images folder you can see this background image. So we are using this image as background. After that we got a column widget, and in this column widget we got several containers. So there you can see we got 4 containers. So firstly in the first container we are just displaying this text widget which is showing this text entity extraction. After that, in the second container, we are showing this text field where user will gonna enter or paste the text that he want to pass to our entity extraction model. So we got this text field widget and we are setting the controller here. Similarly, you can see this hint text, type text here. Similarly, let's look at our third container which is containing our button. So there you can see it is containing this elevated button with the text extract entities. And we got this on pressed listener set on this button. So now when the user will gonna click on this button, we are calling this extract entities function, and we are passing the text that user have entered inside this text field. And we have declared this extract entities function here above. So for now this function is not containing anything, but later we are gonna perform our entity extraction inside this function. Similarly, let's look at our fourth container. So this container is containing a text widget which is displaying the text extracted entities. So we are displaying the text which is stored inside this result variable, and we have declared and initialized this variable here. And for now it is showing this text extracted entities, but later we are gonna store the results our model have returned, or the entities that our model have detected, inside this result variable, and those results will be visible inside this text widget. So that is the GUI of this application. So now the next step is performing entity extraction and showing the extracted entities to the user on screen. And we are gonna do that inside our next lecture. So see you in the next lecture. And now we can use this entity extractor to extract entities from English language text. And that thing we are gonna do inside our extract entities function, because this function will be called once user will gonna enter some text here, and he will gonna click on this extract entities button. So scroll down and you can see in the container when this elevated button with the text extract entities will be called, we are calling this function and passing the text that user have entered here. And we need to pass this text to our entity extractor model and get the results. So open the documentation page, and here you can see this section process text, and inside it we are passing this text to our entity extractor. So just copy this code and we are gonna paste this code inside our extract entities function. So I'm gonna paste it here, and here you can see we are calling this entity extractor dot annotate text function, and we are passing the text that user have entered inside this text field. So we are specifying it here, and this function will gonna return us a list of entity annotation. So for each of the entity which is present in the text, we will get an object of type entity annotation. Then using this object, we can access the information that our model have returned. So we are iterating this list of entity annotation. So for each entity annotation object present in this list, this loop will be executed. And inside this loop, we can get the information that our model have returned. So you can see couple of errors here. So just remove these 3 lines, and after that let's check the options we have. So for each object of type entity annotation, we can check the options by typing annotation and now add a dot, and there you can see for each object we can get the text. So this text will be the text of entity that our model have detected. Like if our text is containing some address, then this text will gonna return us the value of that address. After that we got this end and start variables, and these variables are actually indicating the starting and ending index of that entity text in the string that we have passed. And then finally we got this list of entities, and this list is actually containing the list of entities associated with this text. So there are chances that multiple entities are associated with single piece of text. So in that case we are getting this list of entity, and we can also iterate this list of entity, and for each entity we can get the type. But for now let's firstly display the text of that particular entity. So using this annotation.text, we are gonna get the text and we can simply print it in the console. So let's print it. After that add a semicolon, and that's it. So after printing the text of each entity annotation, we can also print the type of that entity. So inside this for loop, let's remove these 2 lines, and now we are gonna print the type on console. So print and then entity dot type, and then we can get the name for that type. So we are gonna print the text of the entity and the entity type in the console. So now when we are gonna run this application, and we are gonna add some text which contains some entity, and then we are going to click on this extract entities button, in the console we will get the text which is indicating the entity along with the entity type. So let's run this application inside our emulator again, and then we are gonna test it. After that we will show the information detected in this text widget. So let's run this application again. So I'm gonna stop this main.dot and install it again. So now the application is installed again. So let's type some text here. as the entity can be a phone number, address, credit card number, and so on. So here let's type the text which contain a number. Like I'm gonna type my phone number is, or you can type some other text which contains some entity like an address. So here after doing that, when you are gonna click on this extract entities button, we should get the results in the console. So here in the console, let's scroll up and there you can see we got this phone number text here and below we got this phone. So basically we are printing two things. Firstly, the entity text or the annotation text, which is the phone number itself. So you can see we got the exact phone number here. Similarly, we are printing the entity type. So as this is of type phone, so we are getting this type phone here. Similarly, let's test it for a different text. Like I'm gonna type my address. So my address is 34th Street, London. So now when I click on this extract entity button, in the console I should got an entity type of address. So scroll down and there you can see we got this text 34th Street, London along with the entity type address. So our application is working correctly and it is recognizing the entities present in the text. And now let's show this information on screen in this text widget. So there you can see inside our GUI we got this section which is displaying this text extracted entities. So there we are using this result variable. So you can see this result variable here and we are displaying it inside our text widget. So you can see we are using it here. So now we need to store the extracted information in this result variable so that it will be visible on screen in this text widget. So here inside our extract entity function, we are gonna store the information in that result variable. So firstly we are gonna use this result variable here and we are gonna concatenate it, and inside it we are gonna store the entity text. So notation.text will gonna return us the text of that entity. After that add a semicolon. Now along with the text we can also add the text like entity text. So now before this entity text we will get this text entity text, and we can also use interpolation here. So just click here and replace with interpolation, and now the interpolation is being used. So after showing the entity text or the annotation text, we can show the entity type as well. So inside this for loop again we are gonna concatenate our result variable. So result plus equal, and then we are gonna show the type of entity, and before that let's add entity type, and then we are gonna show the type name. So just copy it and add it here, and after that we are gonna add a new line character so that next entity type will be shown on a new line. And similarly we can add a new line character here as well, so that for the next entity or for the first entity type we will get a new line. So now after doing that, again replace it with interpolation, and that's it. So now when this method will be called and we will get our list of entity annotation, we are iterating this list here, and then we are concatenating the results or storing them inside our result variable. So we are adding entity text and then displaying the text of that entity. After that, for that particular entity annotation, we are iterating the list of entities and we are showing the entity type for each entity. So all of this information is now stored inside our result variable, and after this for loop we can simply call the set state block and pass our result variable, so that wherever this result variable is being used the changes will apply, and we are using it here inside our text widget. So there you can see we are using it. So now our extracted information will be visible here, and above this for loop we should reset the value of this result variable, so that next time when this method will be called the previous results will be removed. So let's reset its value here, and that's it. So now let's run the application again, and then we are gonna test it. So now the application is installed again, and we can test this application by typing some text here, or also we can paste some text here. So when you will open the documentation page, and here at the top you can see this link, Google ML Kit Entity Extractor API. So just click on this link, and here we got the official documentation. So there you can read the entity types like address, date, time, email address, and below we got some sample text. Like here we got a text which is using a phone number along with the payment card. So just copy this text, and then we are gonna paste it inside our application and test it. So here long press and paste the text here. Now click on this extract entities button, and there you can see we got this entity text which is actually a phone number, and then we got the entity type which is a phone. Similarly, let's choose some different text, like I'm gonna choose this second text, and I'm gonna paste it inside our application. So here let's remove this previous text, and then we are gonna paste it again and click on this extract entities button. You can see now we got two entities detected. Firstly, we got this text tomorrow which is of type date time, and then we got this text info@google.com which is of type email. So now it is also detecting multiple entities. Similarly, you can test this application for other type of entities as well. But for now, this application is working well, and it is detecting the entities present in the English language. Similarly, you can also use some other language, but for that purpose, again, you need to download the model for that language, and then you can use it. Now there is one more thing that we can do or add inside this application, and that is before calling this annotate text function, we can check if the model for that particular language is downloaded or not. As above, we are verifying if the model is not downloaded, then we are not creating an instance of type this entity extractor. So here inside this extract entities function, we can check whether this entity extractor is not null before using it, or we can also use this isDownload variable and verify that our model is downloaded before we are gonna call this function. And in order to do it, we need to declare this isDownload variable above. As you can see, this variable is model downloaded, so let's rename it to this isDownload. And now let's remove this declaration inside. So we are declaring this isDownloaded variable here, and it is by default false. And now inside this method, we are checking if the model is downloaded or not. So if the model is downloaded, then this variable will be true, and we are not going to download it again. And here we are also gonna initialize our entity extractor. And if the model is not downloaded, then this variable will be false. And here we will try to download the model. And if the model is successfully downloaded, then again this variable will be true. Otherwise this variable will remain false. And we can use this variable here inside this function as well. So we can check if this is downloaded variable is true. Only in that case we are gonna perform all of these things. Otherwise we can display some message, or again we can try to download the model. And here you can do something like that and call this check and download model function in the else block. So else you can again call this function check and download the model. So if the model is not downloaded, then again this function will be called, and inside this function we will try to download the model again, and we will try to initialize our entity extractor. So that is one more thing that you can add inside this application. Welcome to this lecture, As previously, we have completed our entity extraction application, and now it's time to review the process that how we have built this application. So firstly, we got our starter application code from GitHub, and in that application we got the GUI related code. So we got this text entity extraction, then we got this text field where user will gonna enter some text, and then this extract entities button, and when the user will gonna click on it, we are gonna pass the text that user have entered here to our model. And finally we got this fourth portion where we are gonna display the extracted entities. So after getting the starter application code and covering it, we added a library Google ML Kit entity extraction inside our pubspec.yaml file. Then inside our main dot, we created an object of type model manager, and we are calling this check and download model function. And inside this function, we are verifying that the entity extraction model for a particular language is downloaded or not. So we are checking it for English. So we are checking if the model for English is downloaded or not. And if the model is not downloaded, we are downloading it using our model manager. And then we are creating our entity extractor. And after that, when the user will gonna enter some text here and he will gonna click on this extract entity button, we are calling this extract entity function. And here we are passing the text to our entity extractor annotate text function. And this function will gonna pass this text to our model, and our model will gonna return us the results in the form of this list of entity annotation. Then we are iterating this list, and for each entity annotation we are getting the text which is actually the text of that entity, and after that we are getting the entities associated with this text. So we are getting the list of entities and we are iterating them. So for each entity we are printing its type in the console and also showing this type inside this text widget. So that's how this application is working. That user is pasting or entering some text here in this text widget, and then we are passing it to our model, and then based upon the information returned by the model, we are showing this entity's information in this text widget. Welcome to Digital Ink Recognition section of this course. With MLKit Digital Ink Recognition API, you can recognize handwritten text on a digital surface in hundreds of languages. Apart from that, you can also classify sketches and emojis. So by using this API, we can write the text on screen instead of typing it on a virtual keyboard. And apart from that, we can draw some characters which are not available on keyboard, such as these characters. And in this section, we are gonna use this feature of MLKit library and build a Flutter application. And the API provides a number of features, like we can convert our handwritten text into sequence of Unicode characters. Apart from that, the model runs on the device in near real time, which means that our results will be returned much more quickly. Then the user handwriting stays on the device, so there is no chance of data hacking, because no data will gonna leave the device and the recognition will be performed on the device itself. Apart from that, the library supports more than 300 languages and 25 plus writing systems. So you can write the text in any of the major languages like Chinese, Japanese, Korean, Arabic, English, and so on. And apart from recognizing the text, you can also recognize emojis and basic shapes. Similarly, when we are using this library, we will not get any storage related issue, because by using this library, you can download the model for different languages as per your needs. Similarly, you can delete the model when you want, so we will not get any storage related issue by using this library. And in this section, we are gonna build a Flutter application in which user will draw some text, shapes or emojis on screen using his finger. And then that drawing will be passed to our ink recognition model, and we are gonna show the detected text, shapes and emojis on screen to the user. So as the section involves building a very exciting application, so let's begin. Hello and welcome to this lecture. In this lecture, we will start building our digital ink recognition application in Flutter. So in this application, user will gonna write some text with the help of his fingers or using some smart pen. And we are going to detect or recognize that text that he has drawn with the help of his fingers or using any smart pen. So basically it is an application to recognize handwritten text. So let's begin. So the first step is getting our starter application code from GitHub. So open your browser and type this URL, or you can take this URL from course resources. And once the repository page is open, just click on the code button and copy this repository link. Then open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the application is imported successfully. So let's firstly install this starter application inside an emulator and see what does this starter application contain. And after that we are gonna perform digital ink recognition. So I am going to install this application inside an emulator. So now the application is installed inside this emulator, and that is the GUI of this application. So here at the top you can see draw in the white box below. So as in this application we are recognizing handwritten text. So we need such view where user can draw something using his finger or using some smart pen. So that is the white box. And in that box, when we are gonna slide our finger or a cursor, you can see the line is being drawn. So like when I will type or write H here, you can see it is visible here. Similarly, whatever you will draw or write here, it will be visible. And when you want to clear it, you can simply click on this clear pad function and it will be cleared again. Similarly, you can draw anything that you like, and after drawing that text or writing that text, you need to click on this read text button, and we are gonna recognize that what user have written with the help of his fingers here. So that will be the flow of this application, that user will gonna draw something here with the help of his fingers, and then we are gonna recognize it. So after looking at the flow of this application, let's look at the application code. So firstly, open our pubspec.yaml file, and here in the dependencies you can see this dependency Google ML Kit digital ink recognition. So this is the library which we are gonna use to perform digital ink recognition. And you can find this library by opening your browser, and here you can search for pub.dev. And once this site is open, just search for digital ink recognition. Now here in the search results, you can see this Google ML Kit digital ink recognition. So just click on it. So that is the documentation page for this library, and in order to install it, just click on this installing section and you will find the dependency. So there you can see this dependency. So we added this dependency inside our pubspec.yaml file. After that, open our main.dot file and we got our remaining code there. So here firstly let's look at the GUI. So in the GUI we got a scaffold, and then in this scaffold we got this column widget, and inside column we got multiple containers. So in the first container we are simply displaying this text draw in the white box below. And then we got this second container in which user can draw anything with the help of his fingers. So that is the container, and inside it we got the code which is enabling us to draw anything on screen. And we will cover this code in just a moment. And after this container we got this third widget which is a pending widget, and it contains this row. So in this row we are displaying two buttons. Firstly this elevated button with the text read text, so that is this button, and then the second button is for clearing this pad, so it is with the text clear pad. And when the user will gonna click on this read text button, we are calling this method recognize text. And for now in this method we got nothing, but later we are gonna add the code to perform digital ink recognition inside this method. And secondly, when the user will click on this clear pad function, we are calling this clear pad function, and inside it we got the code to clear this view. and we will cover this code in just a moment. And below this padding widget, we got this text widget, and it is displaying this text which is stored inside this result variable. So we declared this variable above, and in that variable we are storing the text. Recognized text will be shown here. So there you can see below our buttons we got this text. Recognized text will be shown here. So that is the GUI of our application, that we got this white box where user will gonna draw or write the text, and below that we got these two buttons, and once the user will gonna click on this read text button, we will perform digital ink recognition, and once he will gonna click on this clear pad function, we are gonna clear that view. And below that we got a text widget, and in this text widget we are gonna display the recognized text. So whatever text user will gonna write here, after recognizing it using our model, we will show that text here in this text widget. And now let's cover the code that how user is able to draw the text on screen inside this white box. And here inside our GUI, you can see we got a container for that purpose. And in this container, firstly we are setting the color to white and then choosing the width and height to 370. And inside this container we have this gesture detector widget, and this is the widget using which we can detect the actions of the user that he is performing on screen. So here we got this widget, and inside it we got three methods: this onPan start, this onPan update, and this onPan end. And with the help of these methods we are able to detect that what user is performing on screen, like when he is putting his finger on this view, and when he is lifting it or he is dragging his finger on that view. So inside this gesture detector we can place a widget, and in our case we have put this custom paint widget, but we can place some other widget as well. And whenever user will gonna interact with this children of gesture detector, this detector can detect the actions of the user. So whatever action user will gonna perform on this child widget, this gesture detector can detect it. So for example, when the user will gonna put his finger in this white box, then this onPan start method will be called. And when he will gonna drag his finger, for each point where he will gonna drag his finger, this onPan update method will be called. And when he will gonna lift his finger, this onPan end will be called. And you can check that by looking at the messages printed in the console. So here when I will expand it, and now when I move the cursor here in this white box area and left click, you can see in the console we got this message onPan start. And when I drag it, you can see onPan update method is being called continuously. And after that let's drag it further, and when I'm gonna lift it, you can see onPan end method is being called. So that's how these methods are being called. And inside each of these methods we got this drag update detail object, and using this detail object we can get the location where user is moving his finger or the cursor, and we are using these details and we are able to draw those points on screen. So as in our case, we are drawing these blue lines exactly where user is moving his finger. So in order to understand that, we need to look at our child widget. So the children of our gesture detector is this custom paint widget, and with the help of this custom paint widget we can draw anything on screen, like we can draw circles, rectangles, lines, arcs, points, and so on. And in this custom paint widget we need to specify a painter, and this painter is actually a class which is extending a class named custom painter. So we have this signature class inside our code, so we created it and it is extending custom painter. So when we extend a custom painter class, we get a method called paint, and inside this method we can access a canvas, and now we can draw anything on this canvas. So whatever thing we are gonna draw on this canvas will be visible inside our custom paint widget, and we are showing this custom paint widget inside our gesture detector. So whatever thing we are gonna draw on the canvas of this paint method, it will be visible on screen. And in our case, inside paint method we are drawing the lines. But how we are drawing them? So we are drawing them with the help of this ink object, and we did not cover that what is this ink object. So this is actually a class which is present inside our digital ink recognition library. So when we talk about digital ink recognition, there are mainly three important things. The first one is a stroke, the second one is a stroke point, and the third one is this ink object. So firstly, let's look at a stroke. So what is stroke? So stroke is an action when the user will gonna put his finger on the screen and he will gonna drag it. And when he will gonna lift his finger, one stroke will gonna complete. So as I have drawn this line, so this will be considered as one stroke. And when I draw another line which is extending from here to here, so this whole end will be considered as a single stroke because I completed it without lifting my finger. So that is one stroke. And this stroke is consisting of many points, which is indicating that where it is starting and where it is moving and where it is ending. So it is actually a list of points, and those points are called stroke points. So stroke points are forming a stroke. Or in other words, a stroke consists of multiple stroke points, which is indicating that where that stroke is present. Similarly, this ink object is actually consisting of multiple strokes, as a stroke consists of multiple stroke points. Similarly, this ink object consists of multiple strokes. And you can see inside this class, we are getting an object of type ink, and then we are getting the strokes present inside this ink object. So for each stroke present inside this ink object, this loop will be executed, and then we got another loop which will gonna execute for each point present inside the stroke. So this loop will gonna run for points present in each of the strokes. So here we are firstly getting the point present at the 0th index and the 1 index, and then we are drawing a line joining these 2 points. So there canvas.draw line will gonna draw the point, and in this function we need to specify three things. Firstly, an offset object where the line will gonna start, and secondly an offset object where the line will gonna end, and the third parameter is a paint object. So here we are creating two offset objects, firstly using this point 1 and secondly using this point 2. So a line will be drawn joining this point 1 with the point 2, and the third parameter is this paint object. And using this paint object you can choose the color and width of the line, like we are choosing the color to blue and the width to 4. Similarly, we are choosing the type of points to round, but you can also choose the square option here. So now when this loop will be executed, for each stroke which is present inside this ink object, this loop will be executed. And then for the points which are present inside the stroke, we are gonna join them with the help of line, and we are gonna draw those lines on this canvas. And when these lines will be drawn on the canvas, they are visible on screen inside our custom paint widget, as we are using this signature class inside this custom paint widget. So when the user is moving his finger on this screen, with the help of this custom paint widget, we are able to show those lines exactly at the position where he is moving his finger. But how we are getting the points and constructing this ink object? So you can see we have declared this ink object above. So here we declared it and we initialized it inside our init state method. So till this point this ink object is empty and it is present inside our digital ink recognition library. So there you can see we imported this library as dir. And the reason is there are multiple ink objects present inside different libraries. So when we remove this dir from here, you will see an error. And the reason is this material library is also containing an ink object. So we need to specify the prefix here. So let's add it and the error will be gone. So after creating an object of type ink, we are populating it inside our gesture detector, because we need to know that where user is moving his finger, and we can get them with the help of this gesture detector methods. So when the user will gonna put his finger on this screen, then this onPanStart method will be called. And here inside this method, we are gonna add a stroke inside our ink object. But in this stroke, we did not added some points yet. And the points will be added once user will gonna move his finger on screen. And in that case, this onPanUpdate method will be called. And here we can get the point that where user is moving his finger, and we are gonna get that with the help of this drag update detail method. So wherever user will gonna move his finger, for each pixel this onPanUpdate method will be called. And inside this method we are using this detail object and getting the location that where he is moving the finger. So there you can see with the help of this detail.localPosition we are gonna get that position, but we are scaling it to get the exact location that where the finger of our user is. So here firstly we are calling this find render object method and getting this render object. After that we are calling this global to local method of this render object, and then we are passing the position where the finger of our user is. And this method will gonna scale the position and we are gonna get the correct position. And we are storing it inside our local position variable, and then we are checking if this variable is not null. So in that case we are gonna create a stroke point and we are gonna add it inside our list of stroke points. So this underscore points is a list of stroke points we declared above. So here you can see this empty list and it is of type stroke point. So now when the user will gonna move his finger, we are gonna add a stroke point inside this list, and we are generating it by specifying three values. Firstly the x position, so we are getting it using this local position.dx, and then the y position, and we are getting it using local position.dy, and there is a third parameter and that is very important, and that is the time for that stroke point. So for each of the stroke point we have the time that at what time this point was actually created. So here we are getting it using our datetime.now function, and then we can get the time in milliseconds, and we are passing it to our stroke point. So now apart from the position where user is moving his finger, we are also getting the time that where the user have moved his finger first and where he has moved his finger later. And this information will be used by our digital ink recognition model to recognize the text. So here after creating our stroke point object, we are adding it inside our point list, and after that the next thing is adding this list of stroke point inside our stroke object, as we have already added it inside our list of strokes which are present inside this ink object. So here we are gonna get the last stroke object and we are gonna assign the points list to the point of our last stroke. So there you can see we are assigning it here. So now we are adding the points where user is moving his cursor on screen or his finger on screen, and for each of the point we are creating this stroke point and adding it inside this list, and this list is actually being added inside our stroke. So by that way we are adding the points inside our strokes and the strokes inside our ink object. And when the user will gonna lift his finger, we are actually clearing this points array so that for the next stroke this points array will be empty. So here let me quickly repeat the process. So let's clear this pad. And here when the user will gonna point his finger on this view, or he will gonna left click using his mouse, this onPanStart method will be called, and a new stroke object will be added inside our list of strokes which is available inside this ink object. And after that when he will gonna drag his finger, this onPanUpdate method will be called for each point where he is moving his finger. And there we are getting the location using this detail object, and we are creating stroke points and adding it inside that stroke. And once he will gonna lift his finger, this onPanEnd method will be called, and here we are just clearing our list of points. But during this onPanStart and this onPanUpdate, a new stroke will be added inside our list of strokes, and the points will be added inside that stroke. So hopefully you got the idea that how we are capturing the points that where user is moving his cursor. So by that way, each of the stroke will be added inside the sync object and we are passing it here inside our signature class. And this whole process of adding points inside stroke is happening inside set state block. So wherever the sync object is being used, the changes will apply. And we are passing it here, so our signature class or our custom paint widget will be updated on screen each time this onPanUpdate method will be called, or each time user will gonna drag his finger. So that's why we are getting this line visible on screen immediately when user is moving his finger on screen. So hopefully you got the idea. So for now, we are using this gesture detector to detect the actions of user on screen, and based upon his actions, we are creating and populating our ink object. And we are passing it to our signature class, and this class is drawing those lines on screen using the information of this ink object. So here we are iterating the strokes of our ink object, and for each stroke we are getting the points and then drawing the lines joining those points. And the next thing is passing this ink object to our digital ink recognizer so that our model can use the information of this ink object and detect the text that user has drawn. But before that, we got another thing, and that is this clear pad function. So when the user is clicking on this function, this view is clearing. And how we are achieving that? So when the user will gonna click on this button, this clear pad function is being called, and inside this function we are actually clearing our ink object. So we are removing all the strokes from this ink object. So we are calling this underscore ink dot stroke and then calling the clear function. So now all the strokes will be removed from this ink object, and we are doing that inside our set state block. So now when this custom paint widget will be shown on screen again, this time our ink object is not containing any stroke. So this loop will not be executed and nothing will be drawn on screen, or our screen will be empty. So this is giving an impression that this pad is being cleared. Similarly, inside that method, we are also clearing this list of points and setting our result variable to an empty string. So that's how we are able to draw text on this view on our screen, and we are able to clear that view by clicking on this clear pad function. So hopefully you got the idea. And in order to perform this digital ink recognition, open the documentation page, and here you can see this block, this processing, and here you can see we are calling this digital ink recognizer dot recognize method, and here we are passing our ink object. As we have already created our ink object inside our application, and we are adding the points or strokes inside it. So we just need to call this recognize function of our digital ink recognizer. So just copy last few lines and paste them inside our application. And we are gonna paste them inside this recognize text function. So here we are using our digital ink recognizer, and we are calling its recognize function, and here we need to pass our ink object, which is named underscore ink. And when this ink object will be passed, our model will gonna use the strokes available in this ink object, and it will gonna recognize the text, and then we are gonna get the results in the form of this recognition candidates. So we will get this list of recognition candidate, and for each recognition candidate we are gonna get the recognized text and the confidence score. So our model will gonna return multiple predictions once user will gonna write something here and click on this read text function, and we can iterate those recognitions and use the best result. So our model will gonna return multiple predictions each time we are gonna pass the data to it, and then we can show those predictions on screen or use them as per our use case. Like here, after getting this list of recognition candidate, we are simply iterating this list and we are getting the recognized text here. And now we can simply show this recognized text on screen inside our text widget. So there you can see inside our application, we are also displaying this text widget which is showing the text present in this result variable. So now we can simply store the results inside this result variable, and those results will be shown inside our GUI. So here use this result variable, and after that let's append it. So we are gonna show the recognized text, and after that we are gonna add a new line so that each of the recognized text or each of the candidate will be shown on a new line. And after the for loop, or once we are gonna store all the candidates data inside this result variable, we can simply call the set state block and pass our result variable here. So now wherever this result variable is being used, the changes will apply, and we are using this result variable inside our text widget to display the text. Similarly, you can also reset this result variable above this for loop so that whatever text it is containing will be removed. Similarly, we should add one more thing inside this recognize text function, and that is checking if the model is downloaded or not before we are using this digital ink recognizer. So as you can see, we are using this is model downloaded variable. So if our model is successfully downloaded, then this variable will be true. So here we can simply use this is model downloaded variable inside an if condition. So if model downloaded is true, only in that case we are gonna do that thing. Otherwise, in the else block, we can show some message like a toast or a snack bar, or even we can show the text inside our result variable like model is not downloaded yet. So in that case, we are gonna show the text, and that's it. So now we can simply run this application inside our emulator again and test it. So firstly we need to click on this stop button. After that we are gonna install the application again. So now I have installed the application again, so let's test it by firstly drawing a letter. So I'm gonna draw H here. And now let's click on this read text button, and you can see we got these predictions here. So we firstly got this capital H, which is 100% correct. Similarly, we can test it for a word, so I will try to type hello here. As I am using a mouse, so it is very difficult to draw the characters here. So hello. And now click on this read text button, and you can see we got 100% right prediction, which is hello with the capital H. So our application is working correctly, and we are able to recognize the text using our digital ink recognition model. So now we have tested our application and it is working quite accurately. So let's quickly review the process that how we have built this application. So firstly we got our starter application code from GitHub, and in this application we are using this Google ML Kit digital ink recognition library to perform text recognition. After that, in the GUI of this application, we got this gesture detector to detect that what is user drawing on that screen. So inside it we are getting the points that he is covering while moving his finger on screen, and for each of his single move we are creating and adding the points inside our ink object. So this ink object is containing multiple strokes, and each stroke is containing the points that user is covering on screen with the help of his finger. So now we got all the data inside this ink object, and in order to display the data, like in order to display these lines which will be visible on screen when the user will gonna move his finger, we are using this custom paint widget, and inside it we are passing our ink object to the signature class, and the signature class is drawing the points present in this ink object. So for each stroke which is present in this ink object, this loop will be executed, and now for each point present in each of the stroke we are gonna draw a line joining them. So these lines are visible on screen because of that class. After that, when the user is clicking on this read text function, we are calling this function recognize text, and inside this function we are performing digital ink recognition. So we are firstly declaring and initializing our digital ink recognizer. So there you can see inside this check and download model, we are checking if the model for a particular language is downloaded or not. So if you want to use this feature for a particular language, firstly you need to download the model. So using this model manager, you can check if the model for that language is downloaded or not. So if the model is not downloaded, then you can download it. And once the model is downloaded, you can create your digital ink recognizer for that particular language. After that, inside this function, we are using the recognize method of this digital ink recognizer, and we are getting the list of recognition candidates. Then we are simply iterating this list and showing the results on screen to the user. So we are simply appending this result variable, and we are using it inside our GUI inside this text widget. So now whatever results our model have returned will be visible on screen below these buttons. Like here, when I type A and click on this read text function, you can see we are getting the recognitions shown here. So that is our digital ink recognition application. Welcome to pre-trained TensorFlow Lite model section of this course. In this section, we will learn to use some of the popular pre-trained models inside our Flutter applications. And we are going to perform some common tasks like image classification and object detection. TensorFlow Lite is a set of tools to help developers run machine learning models on mobile and other devices. We have machine learning model trained on variety of datasets, but to use those models on mobile or other small devices, they need to be converted into a TF-Lite format using TensorFlow Lite library. And in this section, we will learn to use those TensorFlow Lite models inside Flutter. Apart from that, we will cover all important concepts regarding TensorFlow Lite, like the difference between float models and quantized models. Firstly, we will learn to use image classification models in Flutter with both images and the live camera footage. So, we will learn to download image classification models, analyze those models, and use them inside our Flutter application with both images and the live camera footage. Secondly, we will combine object detection feature of our ML Kit library with different image classification models to perform object detection with both images and the live camera footage. So basically, we will use the object detection model of our ML Kit library to detect or locate the objects. And then in order to recognize those objects, we are going to use the image classification models. So we will learn to download different image classification models, analyze them, and use them in Flutter to recognize detected objects. Apart from that, we will learn about a platform called TensorFlow Hub. TensorFlow Hub is a repository to download pre-trained machine learning models for mobile and other platforms. There are a number of ready-to-use models which we can directly download and use, and we will learn to use them in Flutter. So let's begin. Hello and welcome to image classification using pre-trained model section of this course. As we have used the image labeling model of our ML Kit library in Flutter with both images and the live camera footage. So the default image labeling model can recognize more than 400 different items. But now we will learn to use existing image classification models in Flutter with both images and the live camera footage. So in this section, we will explore more than 100 existing image classification models and use two of them in Flutter with both images and the live camera footage. And those two are MobileNet model and EfficientNet model. So we will learn to download existing models in a TF-Lite format, analyze those models and extract the information like the input, output and name of classes the model can recognize. After that, we will use them in Flutter with Image Labeling API to perform image classification with images and the live camera footage. As in this section, we will learn to use existing image classification models in Flutter. So let's begin. Hello and welcome to this lecture. From this lecture, we will start learning to integrate pre-trained machine learning models inside our Flutter application. So firstly, we will learn to use pre-trained image classification models inside Flutter with images. And then later, we are gonna learn to use those models inside our Flutter application with the live camera footage. And these models will be in a format called TensorFlow Lite. And this is the standard format to use machine learning models inside mobile devices. So let's begin. So our first step is getting our application code from GitHub. And we are getting this application code which we completed inside our image labeling section. So inside that section, firstly we learn to integrate image labeling inside Flutter with images. So that is our completed application code, and here we are gonna use that code and add our custom image classification model inside it, and then we are gonna use that model. So open your browser and type this link, or you can also take this link from project resources. And once the repository page is opened, just click on this code button and copy this repository link. Then open your Android Studio and here click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now our application code is imported. So let's firstly run this application inside an emulator and see whether this application is working or not. And after that we are gonna add our custom TensorFlow Lite model inside it, and we will perform image classification using that model. So I am going to install this application inside an emulator. So now our application is installed inside this emulator, and in this application we are performing image labeling with images. So user can choose an image from gallery by clicking on this camera icon. So there you can see our emulator gallery is opened, and here we can choose any image. So we are gonna choose this car image, and there you can see below this image we got the predictions. So the first prediction is vehicle with the confidence score of 97%. Similarly, we got the prediction car with 92% confidence score. And we got some other prediction as well. And all of these predictions are quite related to this image. So our application is working correctly, and in this application we are using the default image labeling model of our ML Kit library. And now we need to use our custom image classification model inside this Flutter application. So we can get some popular pre-trained image classification models and use them inside this application. But those models must be compatible with our MLKit library. And in a moment we will see what will be the criteria to use the model with our MLKit library. But for now, let's quickly look at this application code. So firstly, inside our pubspec.yaml file, we got the dependencies. So there you can see we got this image picker library, and with the help of this library, we are choosing images from gallery or capturing them using camera. Similarly, we got this Google ML Kit image labeling library, and by using this library, we are performing this image labeling. And inside our lib folder, we got our main.dot file, and here we got the code. So firstly, you can see inside our init state, we are initializing our image labeler. And then we got these methods image from camera and image from gallery. So when the user will gonna click on this image from gallery will be called, and when he will gonna long press on it, this image from camera will be called. And here we are choosing or capturing the images. And after that we are calling this do image labeling method, and inside this method we are performing our image labeling. So there you can see firstly we are getting the image that user selected or captured and converting it into our input image format, and then we are passing it to our image labeler and getting the list of image labels, and then we are simply iterating this list and showing the result to the user on screen. And we have built this application inside our image labeling section of this course, so you must complete that section so that you can understand this code completely. And now inside our next lecture, we are gonna download some models which we can use inside this application and perform image classification using them. So, see you in the next lecture. Welcome to this lecture. As previously, we have downloaded this MobileNet model from TensorFlow Hub and we have added it inside our Flutter project. And now it's time to use this model and perform image labeling inside this Flutter application. And to do that, we need to open the documentation page for this library, Google ML Kit Image Labeling. And this is the library we are using to perform image labeling in Flutter. And we have already added it inside our pubspec.yaml file. So now on this documentation page, when you are gonna scroll down, you can see this section load local custom model. And the first instruction is adding the TF-Lite model inside your project and declaring it inside your assets folder. And we have already done that. And the next step is adding this method inside your main dot dot. So this is the method which is taking our model file path and it is returning the true path which can be used by our image labeler to load the model and perform image labeling. So we need to paste this model inside our main dot dot. So just copy it without these imports. So I'm gonna copy it and open the project. And here above this do image labeling method, let's paste it. And there you can see several errors. And these are because of the imports. So copy the imports as well and paste them at the top of our main dot dot file. So I'm gonna paste them here at the top of our main dot dot. And there you can see we got this error for our path provider dot dot. And the reason is it is an external package and we did not add it inside our pubspec.yaml file. And we are gonna add it in a moment. But for now, when you are gonna scroll down, you can see some other errors inside this method. And to remove them, just remove this text from here, here, and here. And now the only error is for this get application support directory, and this is the method of our path provider library. So now let's add this library inside our pubspec.yaml file. And to do that, open your browser and go to this site pub.dev. So I'm gonna open it inside a new tab. And here you can search for path provider. Press enter and in the search result you can see this library. So just click on this installing button and there you can see this dependency. So just copy it and paste it inside your pubspec.yaml file. So here inside our dependency section, I'm gonna paste it below this Google ML Kit image labeling. Now click on this pubget so that the library will be downloaded and added inside our Flutter application. So there you can see the library is downloaded and now when you are gonna open the main dot dot you can see this error is gone along with the error for our path provider. So now we have pasted this method and the next step is using this method and loading this model. And to do that, open the documentation page again. And here when you are gonna scroll down, you can see the next instruction is creating our image labeler. But this time we are gonna create this image labeler using our TF-Lite model. As previously we are creating our image labeler inside our init state, but that image labeler is using the default model. But now we want to create this image labeler using this mobilenet.tflite file. So in order to do that, open the documentation page and copy these 3 lines. After that, inside our main dot dot file, let's create a new method. So I'm gonna create it here and name it create labeler. And now inside this method, let's paste these 3 lines. And now let's take a look. So there you can see, firstly we are calling this getModel function and passing the path of our TF-Lite model. As in our case, our model file name is mobilenet.tflite, so just rename it here. So now we are passing the path of our TF-Lite file, and this function will gonna return the true path which can be used by our image labeler to load the model. So we are storing this path here inside our model path variable, And after that we are creating our local labeler option. As previously we have told you that this image labeler option is used to customize our image labeler. So in case of default model, we are choosing our confidence threshold using it. And now in case of our TF-Lite model file, we are passing our model path inside this local labeler option. And then we are specifying it here inside our image labeler. So now when these lines will be executed, our mobilenet.tflite model will be loaded because of our ML Kit library. Similarly, you can see this error for await, and the reason is we need to add this asynchronous modifier. So just click on this await and press Alt plus enter and you will see this option. So let's add this asynchronous modifier and the error will be gone. So here you can see inside this method we are loading this mobilenet.tflite file and creating our image labeler. So now we need to call this method here inside our init state. So previously where we are creating our default labeler, there let's remove this code and call this method. So call this create labeler method, and after that we need to remove this final from here. And the reason is we already declared our image labeler here. So when this init state method will be called, here we are calling this create labeler, and inside this method we are gonna load our TF-Lite model file and create our image labeler. And now we can use this image labeler to perform image classification. And this time this mobilenet.tflite model will be used instead of the default image labeler of our ML Kit library. So now we can simply run this application inside the simulator again and test it. And we don't need to change anything inside this application. And the reason is, previously we are using the default image labeling model of our ML Kit library. So we are loading it using that code. And now we want to use this MobileNet model, so we just need to load this model and create our image labeler, and the remaining code will be same. So now when the user will gonna choose or capture the image, then this do image labeling method will be called, and inside this method we are gonna use our image labeler and we are gonna perform image classification. But this time this image labeler will be using our mobilenet.tflite file. So let's run the application again and test it. So I'm gonna simply click on this stop main dot and install the application again. So now our application is installed again, and here we can test it by choosing an image from gallery or capture it using camera. And this time we are using this mobilenet.tflite model. And as I told you before that this model can recognize up to 1000 different items. And those things are present in this file. So this is the label file associated with this mobilenet.tflite, and I have extracted it. And inside our next lecture we are gonna cover the process that how we can get the names of the classes which our model can classify. But for now we are gonna quickly test this application, and then inside the next lecture you can extract this labels.txt file and test the application again for the classes which are mentioned inside this file. So you can see a number of classes are present here. So let's minimize it for now, and we are gonna test it by choosing an image from gallery. So there we have this ostrich image, and this MobileNet model can recognize it. So let's choose this image for now. And there you can see we got the prediction ostrich with the confidence score of 100%. So our model is working correctly. Similarly, let's choose this microphone image. And there you can see we got the prediction microphone with the confidence score 99%. And we are getting these predictions because of our MobileNet model. Because this model can recognize this microphone, ostrich, and 1000 other things. So for now, we have integrated this MobileNet model inside our Flutter application, and we are getting the results. Welcome to this lecture. In this lecture, we will learn that how we can get the names of classes which our image classification model can recognize. As previously, we learned to download the model from TensorFlow Hub, but we did not downloaded any label file which is indicating that what are the classes which our model can recognize. So now here in this lecture, we are gonna do that. So open your browser and here you need to type for Google Colab. Press enter and there you can see this first result colab.research.google.com. So this is a platform provided by Google which enable us to run Python code inside our browser. So just click on this first link and this page will be opened, and this is the default page for this Google Colab. And now we are gonna use this Google Colab to get the label file from our model. So in order to do that, firstly we need to sign in by providing our Google account. So just click on this sign in button and then it will gonna ask you for your Google account. So I'm gonna provide the details of mine, and in your case you need to attach your own Google account. So now after attaching the Google account, you can see your Google account here. And now here we need to create a new notebook. So just click on this file and click on this new notebook. So there you can see our new notebook is created, and here we can write the Python code, and we are gonna just write a single line, and that line will gonna give us our label file where we can see the name of classes which our model can recognize. So on this new notebook, just click on this file icon, and here we need to paste our model file for which we want to get the labels. And here we need to wait until our session is started and we can see this folder here. After that we can simply get our model file and paste it here. So just drop it here and you will see this dialog box. So just click OK. Now our model will gonna start uploading on this Google Colab. And once the model will gonna upload, then we are gonna simply unzip this lite file. And we are gonna do that with the help of this simple command. So just type unzip and then you need to specify the name of your model file. As in our case it is mobilenet.tflite. And that's it. So after specifying this name, we need to wait until the model is uploaded. And once the model will be uploaded, we are gonna execute that command and it will gonna give us our label file. So let's wait for the model to be uploaded. So now our model is uploaded, and here when you will try to execute this cell, you will get an error. And the reason is we need to add this character before this command. And now let's run this cell by clicking on this run button. And there you can see we got this message extracting labels.txt. And in the side pane we can see this labels.txt file as well. So now we got this label file and we can simply download it. So there you can see this file is downloaded. So let's open it. And there you can see we got the labels or the objects which our model can recognize. And these are around 1000 objects which this MobileNet model can recognize. So now you can see the names of things which your model can recognize and test your application by passing the pictures or pointing your camera at those things. So that's how we can get the label file from our model which we downloaded from our TensorFlow hub. Similarly, if you downloaded some other model, you can simply paste it here and then pass the model file name here. And after running this command, you are gonna get the label file, and then you can see the names of the classes which that model can recognize. Welcome to this lecture. As previously, we have completed this image labeling application where we are using our pre-trained MobileNet model. And now let's quickly cover the process that how we actually did that. So firstly we got our application code from GitHub, and this is the application code which we completed inside our image labeling section where we integrated the default image labeling model inside Flutter with images. So after getting this application code, we downloaded our MobileNet model from TensorFlow hub and then we pasted it inside this assets ML folder. So we created these directories and pasted our model file. Similarly, if you are downloading some other model, then you can just download it and paste it inside this ML folder. After that, inside our pubspec.yaml file, we declared this ML folder, and then inside our main.dot file, we added the code to load this model. So we pasted this get model function, and we created this create labeler function. So inside this function, we are calling this function to get the true path of our MobileNet model, and then we are creating our image labeler. And this image labeler will gonna use this MobileNet.tf lite model. And when we pasted this get model function, we also added this path provider dependency inside our pubspec.yaml file, because we are using it to get true path of our model file, which will gonna used by this image labeler to load the model. Apart from that, everything else in this application is same, because now we have just changed the procedure to load the model. We are not using the default image labeling model, but instead we are using this MobileNet model to perform image labeling. Welcome to this lecture. As previously, we have learned to integrate our pre-trained image classification model inside our Flutter application. But there we are using that model with images and performing image classification. And now it's time to perform image classification using our pre-trained model with the live camera footage. So we are gonna build a real-time image classification application where we are going to use the model that we downloaded from TensorFlow Hub. But before starting this application, make sure that you have completed the image labeling section of this course, where we have learned to perform image labeling inside our Flutter application with both images and the live camera footage. Otherwise, you will not be able to understand things completely. So now let's begin. So the first step is getting our application code from GitHub. And this is the application code that we completed inside our image labeling section, where we have built our real-time image labeling application using the default model. So here, once the repository page is opened, just click on the code button and copy this link. After that, open your Android Studio and click on this get from version control. Now paste the link here and click clone, and our project will be cloned in a moment. So now the project is cloned successfully. So let's firstly run this application inside an emulator and confirm that this application is working or not. Similarly, in order to effectively test the application, you should install it inside your real device. But for now, I'm gonna install it inside the simulator. So now the application is installed, and here let's give the permissions. And there you can see inside this application the live camera footage is being displayed, and that is the default preview for our emulator camera. And when you are gonna run this application inside your real device, then you are gonna see that the live camera footage is being displayed, and you will see that it is classifying the objects which are present in the frame of this live camera footage. So you can confirm the working of this application. And now, after importing and running this application code, the next step is integrating our pre-trained model in a TensorFlow Lite format. And to do that, we are gonna repeat the process that we followed earlier when we integrated that model with images. So if you have completed the previous section, then you should do it by yourself and take it as a challenge. And if you're stuck somewhere, then follow me on this lecture. So firstly, we need to add our model inside this Flutter project. And to do that, we need to create our assets folder. So just right click on our project name and create a new directory. And we are gonna name it assets. And there you can see this directory. Now right click again and create a new directory inside it. And we are gonna name it ML. And now inside this ML folder, we are gonna place our model file. So as previously, we have learned to download the models from TensorFlow Hub which are compatible with our ML Kit library. So we are gonna use the same MobileNet model here. So I got it here, so just copy it from where you have pasted it. And you need to paste it inside this ML folder. So press OK and the model will be added. And there you can see inside this ML folder we got this mobilenet.tf lite. And when you are gonna click on it, you can see the details of this model because the model contains the metadata apart from the model file itself. So we can see the input and the output of the model. Similarly, this TF-Lite model file is also containing the names of the classes which this model can recognize. And earlier we have learned to extract those names using our Google Colab. So make sure that you have completed the previous lectures of this section before proceeding to this one. So there you can see this model is taking an input image of size 224 by 224 and it can recognize up to 1000 different objects. So after pasting the model, open pubspec.yaml file and we need to declare our ML folder. So here in this Flutter section, you can see this assets tag which is commented. So just uncomment it and make sure the spacing matches with the spacing of this uses material design. So let's remove one space further. And now here we are gonna declare this folder. So just write this folder in this manner as I am writing it. So type images /ml/. So by doing that we are declaring our ML folder and now inside our application we can use the files which are available inside it. And we have pasted our model. And after pasting the model and declaring it here, the next step is loading this model and performing image labeling. So open this lib folder and go to our main dot. And here when you are gonna scroll down, you can see this initState method. And inside this method, we are loading the default image labeling model of our ML Kit library. But this time we need to load this MobileNet model and perform image labeling using it. And to do that, we need to open the documentation page for our ML Kit library. So here you can see I have already opened it. And you can open it by going to this site pub.dev and there you can search for this Google ML Kit image labeling. And here when you are gonna scroll down, you can see this section load local custom model. And here we got the instructions and the first one is adding the model and declaring it inside our pubspec.yaml file. And we have already done that. After that we need to add this method inside our main dot. So here copy this method but don't copy the imports yet. And after that paste it inside our main dot file above this do image labeling method. And there you can see several errors. And to remove them, firstly remove this IO from here, here and here. And after that we are gonna add the imports so that the errors will be gone. So just copy these imports and paste them at the top of our main dot file. So I'm gonna paste them here. And now you are gonna see that the majority of errors are gone. There is only one error and which is for this get application support directory. And you can see this error path provider . And the reason is this is an external library and we did not added it inside our pubspec.yaml file. So we need to add this path provider so that by using it we can get the exact path of our model file and pass it to our image labeler. So open your browser and you need to find this package path provider. So you can go to this site pub.dev and there you can search for it. And once you are gonna find it, you need to go inside installing section and there you need to copy this dependency. After that, paste this dependency inside our pubspec.yaml file below this dependencies. So I'm gonna paste it here. Now click on this pubget and you will see the error will be gone. So now you can see the library is imported and inside our main dot file the error is gone. Similarly, you can scroll up and you can see the error for this path provider is gone as well. So after declaring this method, we need to use this method and load our model file. And to do that, open the documentation page for our Google ML Kit library again. and here you will find these three lines. So just copy them and open our application code. So above this get model function, we are gonna create a new function and name it create labeler. Now inside this function, we are gonna paste these three lines. And here you can see the first line is calling this get model function and passing the path of our model file. As our model file name is mobilenet.tflite, so just change it here. And that's it. Similarly, you can see this error for await keyword, and we need to add asynchronous modifier and the error will be gone. So here inside this method, firstly we are calling this method and passing the path of our model file. And this method will gonna return the exact path where this model is present inside the device. And then this path will be used by our image labeler to load the model and perform image classification. So there you can see we are getting this model path and we are passing it to our local labeler option. So here after passing the path, we are passing these options to our image labeler. And now here you can notice the difference. As previously we are using the default model, so we were creating this image labeler option variable and choosing this confidence threshold. And then we are passing this option variable here and initializing our image labeler. But now we want to use this MobileNet model, so we need to create an object of type local labeler option. And here we can specify the model path. After that we are passing these options here, and when these lines will be executed, our MobileNet model will be loaded. So now we need to call this method. So here inside our init state where we are initializing our image labeler, let's remove this previous code and call this function. So call this create labeler function here. After that add a semicolon and the error will be gone. So we are declaring our image labeler here, and then we are calling this create labeler function. And inside this function we are initializing this image labeler. So let's remove this final from here, and that's it. So now these are the changes we need to make inside this application to use it with our custom image classification model. Apart from that, everything else will be same. And you can simply run this application inside your real device again and test it. But before that, let's look at the changes again. As previously, we are creating our image labeler inside this init state and we are initializing it. But this time, as we want to use this model, so firstly we added it inside our assets folder, and then we are creating our image labeler using these lines. So we are getting the path of our model file and creating this local labeler option. And then we are passing this option here and our image labeling model will be loaded and we can use this image labeler. And we are using it inside our do image labeling method. So here you can see for the frames of our live camera footage, this process image method will be called and we are passing those frames to our model. But this time we are not using the default model, but we are using this mobilenet.tflite. Similarly, if you downloaded some other model, you can simply place it inside this ML folder and use it for performing image labeling. So now let's run the application again and see whether we are able to perform image classification using this MobileNet model or not. So I am going to install this application again. So now I have installed the application inside my real device, and there you can see when I am pointing it at my keyboard, it is being classified quite well. Similarly, when I am pointing at my screen where I got this trailer truck, so you can see it is also being recognized quite well. I also got this table lamp here, so there you can see our model is detecting it as a lampshade or as a table lamp. Similarly, I got one microphone here as well. So there you can see it is also detecting it. So our application is working correctly and we are able to use MobileNet model for recognizing different things present in the frames of live camera footage. So now we have tested our application and it is working quite accurately. So let's quickly review the process that how we have integrated our pre-trained model inside this Flutter application. So firstly, we got our application code that we completed our image labeling section. So this was the complete application, but we were using the default image labeling model. And now we want to use our pre-trained model. So firstly, we created this assets ML folder and pasted our model. After that, we declared it inside our assets section so that whatever file is present in this ML folder, we can use it. Then inside our main dot file, we have loaded this model using this code. So firstly, we are getting the model path and then creating this local labeler option. After that, we are creating and initializing our image labeler. But this time, this labeler will be initialized using this MobileNet model. So inside this create labeler, we got all of this code and we are calling this function inside our init state. Apart from that, we did not change anything. So we have just changed the process to create our image labeler and load the model. Similarly, if you want to use some other model, what you can do is to paste that model inside this ML folder and then you can specify the name of that model file here. And that's it. You don't need to change anything else inside this application to make it work for a custom pre-trained image classification model. But make sure the model you are using must have a metadata associated with it.